qualche secondo. Ottimo. Parto? Posso? Good morning, everybody. So, welcome to Data Science. I'm really excited today. It's really amazing seeing you all here, sharing this day with us. So, as you might know, we have a tight schedule today. So, our agenda includes some talks given by data science practitioners, some talks given by data science students in their second year, and of course, a detailed description of our curricula and internship program. So I won't waste our time, and I will keep this speech very short. Anyway, before we start, I'd like to thank all the speakers for accepting our invitation, and of course, our administrative staff that helped us in this in the organization of this event and made all this possible. Yeah? And now I would like to introduce Professor Marco Ferrante that will tell you some words, and well.
Okay. Hi, everybody. I'm very happy to be here. And I would like to say in a more correct English what I'm doing here. I'm giving to you the wishes of a rector that is not able to be here today. And I am a vice rector. It's a very tough position, I discovered in the last 6 months. And was much more easier to be the head of data science. I was the former, and I am perfectly substituted by Francesco, and I am one of the father of this course. I have made very many things that I'm very proud of in data science, starting from the T-shirts. The T-shirts is something that I decided to do, the logo, everything, and so this is the only thing that I say it belongs to me. Okay, the other things are we have done with the help of fantastic teachers and very, very, very good students that we are happy to have here. And I wish you a very nice day here. We are very proud. Welcome to Data Science was first scheduled 2 years ago, the week that COVID arrives to the Earth. And we were very unlucky because it was just a question of a week. And we were able to make the first. Welcome to Data Science. We are very brave because we decided to try again. As you know, the situation in the world is not comparable for us, at least now, but is again very tough. And so it was unpredictable when COVID was starting to living our lives. But I am very optimistic and hope that in a few months, humanity will recover the brain, at least part of humanity. And so I wish a wonderful day, and I will not use too much time, and welcome everybody, and Francesco.
So I can now introduce, and I'm proud to introduce our first invited speaker, Samuel Rota Bulò from Meta. So welcome, Samuel, and thanks for accepting our invitation.
Okay, thank you very much, Francesco and Lamberto, for inviting. I'm very happy to be here. Okay, here. So I'm now a research scientist at Meta. Before joining, I was working for Mapillary, and I will talk to you about Mapillary during this presentation. So Mapillary was acquired roughly 2 years ago from Meta. That's why now I'm a research scientist there. And I used to be a research scientist at Mapillary before. And the talk will be about the problem of mapping, but at global scale. In order to achieve this, we leverage computer vision machine learning techniques. Okay, to start, I have a video presentation of Mapillary, and then I will follow up with more about the Mapillary pipeline.
We need more from our maps than ever. From ride services to deliveries, autonomous vehicles, and disaster relief efforts, we depend on knowing what is where at any given moment. Unfortunately, the maps that power all of these services are limited. They're only as helpful as the data that was used to make them. And accessing accurate map data is incredibly complex. First, their scale. We need detailed location data from pretty much every place on the planet. Street signs, points of interest, or where the loading dock is. And there's no way to get that level of data from satellite images alone. The second challenge is freshness. The world is changing far too fast for any single mapping company to keep up. These challenges lead to bad map data and outdated maps, which causes real problems, from late deliveries to losing precious time in a crisis. That's where Mapillary comes in. Mapillary is the collaborative street-level imagery platform that lets anyone access the data they need for making better maps. The Mapillary platform allows anyone with any kind of camera, like a smartphone or an action cam, to easily capture street-level imagery. Those images are uploaded to Mapillary and automatically analyzed with computer vision technology to detect all kinds of features, from road markings to traffic signs. All of the data and the underlying imagery are available to anyone through Mapillary to provide information about what is where, everywhere. This massive body of images and data can be used to validate existing maps and to update and improve any kind of map for all kinds of needs, like making the navigation apps we love more accurate, or cities knowing where every sign is, faster deliveries, or helping people get from A to B faster. In other words, Mapillary helps everyone make better maps.
Okay, so what's the problem we want to address? So we have that the world is changing very fast, and it's very hard to keep maps up to date. And besides few big companies that can have a fleet of cars that can go out and capture, all other users will have difficulties in accessing good map data. Even those big companies, when there are changes, they have to invest money, take their cars, let them go out to remap all the parts where there were changes, and this is not the process that they can do from today to tomorrow, okay? So if you have disasters, for instance, and you really need to map those areas very quickly, even those companies will not be able to deliver updates in their maps. And this is where Mapillary comes into play. And the solution that with Mapillary we created is to try to scale up the problem of mapping by leveraging the help of many people around the world. So it's a crowdsourced platform where people around the world can capture images, upload them on the infrastructure, and then there we can automate the process of extracting map data using computer vision and machine learning. So by having people around the world with their camera, with the arbitrary capturing system that capture images, and we can process them very quickly by computer vision and machine learning algorithms. In this way, we can actually scale up the problem of mapping. And everyone will benefit then from those maps. Okay, so the Mapillary ecosystem consists in people that can capture anywhere in the world with any camera they have available. So we can have people with their phone, mobile phone, iPhone, Android. We provide an app that can be used for capturing. But we can also have images captured with dash cams on the car, or with professional rigs, or sensors on the vehicles. And we get imagery from all around the world. So at the moment, we have 1.5 billion images on the platform, and those cover 190 countries and 6 continents. Okay, let's have a look at a course overview of the pipeline. So we start with images. Now, you have to imagine that we have hundreds of thousands of images that enter the framework every day. So we need to be able to process all those images and store them. And back then, when we were with Mapillary, we had all of our infrastructure on the cloud, because every day we were getting more and more images. We had to scale up our system very quickly. That's why having our servers was not ideal, because we really needed to have from today in a month to scale up our infrastructure. So once we get the images and we store them, we have to process them. And the first thing, important thing that we have to do is to analyze semantically the content of the image. So we want to know what kind of objects or what we have in those scenes. And first of all, one big reason is we need to be able to anonymize those images. So there are regulations. We cannot store images where you can see faces of people or you can read a license plate of a car, in particular because there is a web service where people can go and see all the imagery. And in order to understand where faces and license plates are, we need to be able to recognize them in the images. On top of this, once we know also where the traffic signs are, we are able to classify them and provide then a service where you can know where the traffic signs are. Another important thing is that we want to map, and to map we need to understand the geometry of the word. So we need to be able to have 3D reconstructions of the word starting from the 2D images that we get in input. And to do 3D reconstruction, we actually need to exclude dynamic objects, because the dynamic objects is not something that we want to map. We want to map the static objects, and actually having the dynamic objects will corrupt our computer vision systems that allow us to do 3D reconstruction. So we want to filter them out, and again, we need semantic segmentation for doing that. Semantic segmentation tells us where dynamic objects are, such that we can filter them out. We can then combine them and get semantic point clouds. So we can put the semantics into the 3D space and extract 3D map features. So we know where traffic lights, traffic signs are. We have a lot of objects we can detect, and we can position them in 3D space all around the world. And finally, one can use this information to improve even on the 2D map. Now, consider that we have 3D maps, actually, all at the world scale. But we can use this also to improve the 2D maps, okay? Okay, here is examples of some results from the pipeline. So imagine that we have this capturing. In the system, we have semantic segmentation that will provide you information about the semantic content of those images. So every color here is a different semantic class. We can even recognize the instances, not just the class, but also the instances that we recognize. So here, every car, for instance, every pedestrian, every lamp pole, we know that it's a separate instance. Here we have an application where we can predict the lanes on the road. The red one is actually a lane where the car can drive. And here we have a 3D reconstruction of the environment in terms of a sparse point cloud. And now we can combine this with semantics and get a semantic 3D point cloud. Now every point in 3D space has a semantic category associated. And finally, we can get the instances and localize the different instances of interest in 3D space. So here, for instance, you can see where all the traffic lights are, or the street lamps. And all this is done on the platform. As we get new images, we update this big 3D model of the world. Okay, now, in this talk, since I don't have hours, I want to focus more on the semantic segmentation problem, okay? So what's the problem? Given an image, like this one, we want to assign to each pixel of the image a semantic category. So for every pixel, like a pixel here on the road should get a road semantic category. Sky will get sky, etc. So we will have a dense prediction. Another related task is panoptic segmentation, where we don't want to just know the semantic category. We also want to know the instance ID of a specific pixel. So for instance, we know that all pixels here are of a car. Also, those ones are of a car. But I want to know that all pixels here are of car number 1, and all pixels here are of car number 2. So every instance, we want to know which pixel belong to which instance, besides just knowing the class. Okay, and now think about you as a programmer. And your employer asks you, okay, can you please provide me with a segmentation algorithm? And now you have to write a program to do that, okay? And I mean, you studied maybe conventional programming, and you start trying to solve this problem. And let's say we have Bob. He's a programmer, and he got this assignment. So the first thing Bob does is, I try to look at pictures. So I was asked to segment cars and some other objects. I need to figure out how I can actually write a program that can predict for a pixel of car that it's a car. So you start maybe looking at the images to have an idea. No? Maybe you get some idea. You get the data, look at the data, stare at the data, and you try figuring out, okay, what can I do to actually segment? Maybe you are smart and you say, yeah, objects have a similar color, then you can use color similarity to get some clusters, but still you need to solve the semantics. Maybe at the end you manage to write a program that is able to provide you with a semantic segmentation. Now, what you do? You try to see if that works, so you get more data. You wrote your program, so on the right we have a set of possible programs. Bob wrote one program, and now realizes that, okay, actually this doesn't work on this other set of data. So I was staring at some images, I designed a solution that was working for those images. But now I get new images, and it's not working anymore. So what you do? You try to modify your program such that now it works also on these other images. But then you get more images, and you see it's actually not working there. Sorry. And then you start modifying your program over time, and at some point, the images that were working before do not work anymore. So at the end, it's too difficult. You cannot solve the problem by using conventional programming. So are there alternatives? Okay, so Bob has an idea. So what we can do is to reverse the process. Let's first start collecting data. And not just data, images, but data with annotations. So we know on those images we want to obtain this outcome. And we have many, many images of this kind. Now, it's not easy to collect data because we need to have them annotated. So this is a process that takes time, takes money, okay? But once you do it, you have a data set that can be used for the task. Now, the second thing we need, instead of Bob trying to find a specific program to solve the problem, now Bob starts to design a set of possible programs that could solve the problem. So we create a large set of potential programs. So we characterize a set of potential programs that can solve the problem. Next, we have to specify an objective. So the objective function, given a program, given the data, and given the result that the program provides you on the data, the objective function tells you how well actually you solve the problem. And we know how the actual solution should be because we have the solution, okay? And finally, okay, here an example. I have this program. Well, this is not really solving perfectly the problem, but maybe in this set there is another program that can actually solve the problem in a better way, okay? And the final ingredients is that we don't want Bob to look for the right program that solves the problem. We now just need a learning algorithm, an automatic process that can search for the program that solves the problem, okay? So for instance, we have this program at the beginning with this objective, and the algorithm knows the objective, so it can start searching the space of programs until it gets a program that actually solves the problem for the data we got in input, okay? So did we have an alternative? And yes, it's called machine learning. So machine learning is a science that allows you to get computers to be programmed not explicitly, but implicitly, okay? So we are not providing a specific program to the machine. We let the machine search for the best program for the task, okay? So this is a quotation from Andrew Ng. Okay, now for the semantic segmentation task in Mapillary, the first thing is that we realized that, of course, we need machine learning to solve the problem. And the first step is we need the data. So how do we actually get this data? We created a data set. It took 1.5 to 2 years, because annotating one of those images takes 40 minutes for a human. Okay? It's high resolution, it's dense, every single pixel has to be labeled. And we created this big data set with 25,000 high resolution images. We do, on the platform, we have images all around the world, so we could pick images on our platform, and we took them in a way. So we also covered 124 semantic categories with 100 categories that could be annotated also in terms of instances. We have a global reach, so we pick the images such that we can span the planet and covering all possible continents. But also we wanted to cover a variety of seasons, time of day, cameras, viewpoints. This is important because one thing that I didn't tell you, and you will learn probably in a course, is that picking the right data is important, because otherwise you will have a program that, again, cannot solve the problem in general. Okay? And here is the, okay, there was the website. You can actually go there and query and have a look at the data set. So here are some examples of images that we have that cover different weather conditions: foggy, sunny, snowy, rainy, but also different viewpoints on the highway, in a city, on the sidewalk, or outside of a city. So we need to have data that can span many use cases, okay? Now, programs. We need to specify the set of possible programs. You might think that this is the most difficult thing. It's actually the easiest. Now, what's a program for us? It has to be something that takes an input, an image, and outputs a segmentation, okay? This has to be like that because we want a feasible program, so a program that solves potentially the task. And we can specify a program very simply as a composition of functions. Functions that are parameterized, which means that if I change the parameters, I'm changing the function. And the set of all possible parameters then gives you a large set of possible programs. So here, for instance, I have a stack of functions. Each of those blocks is a function. We take the image, get through the function, the output through another function, etc. And what we have in between are tensors. Now, the input image is a tensor. It's a three-dimensional tensor. We have height, width, and 3 channels, if it's an RGB image. And then, as we process those functions, take this tensor, apply a function that has parameters, could also not have parameters, and creates a new tensor. And this goes in input to another function. So at the end, you transform information until you get to a segmentation output. Initially, it might be all random, no? Because it's initialized like random. But then the learning algorithm will search for one that actually solves the problem. And we have parameters. So imagine that those functions have a set of parameters that we can vary. By varying the parameters, we get a new program, okay? The objective. Now, we have our function, our program, that given an input image provides you with an output. Imagine that the output is, again, an image, okay, with pixels. And we know the ground truth. So we know that we would like this output to look like this one, okay? Now, pick one pixel here. So this should be a road, a pixel. So we would like to get road as an answer. Now, we design the function, the output, such that instead of outputting an index, you know, the class, it outputs actually a probability distribution over all possible classes. So for instance, in this case, the program tells you, okay, I'm pretty confident it's a road, but it could also be sky, tree, and car with some probability. Of course, it's not entirely correct if you say that it's tree, sky, and car. But we know that this should be road. So what we do? We define a loss function that basically tells you, well, how good your answer is with respect to the correct class. And here is not perfectly correct, no? And the loss function should be a function that if you improve the solution, which means that if you would increase road and decrease the other, you get a lower error. So you have a reduced loss, okay? Finally, the learning algorithm. So we start with the data. Let's say we pick a pair of images with corresponding ground truth, okay? And we have one program, okay? This theta is just a parameterization that identifies one program. So you see, we have the parameters there. And this is our set of possible programs, and theta, so this one is just 1 point here. Now what I do, I take this function, assign it, or evaluate it on the image. As an outcome, I get a segmentation output. Then I specify the loss, so I can take the loss and say, okay, what's the loss if I'm predicting this segmentation output given this ground truth? And it tells you, okay, let's see if it matches, no? If it doesn't match, I give you a loss. If it matches, I give you, let's say, 0 loss, okay? And this is just for a pair of images, but I have a huge data set here. So what I do, I go and sum the losses of all possible entries in my data set. And at the end, I have a function of a program. So this tells you how well the program behaves on the entire data set. Okay. Now this is the objective function, okay? So this is an objective, tells you how well your program is. You can imagine that it's like this, and here we have the actual program. Now, if you did optimization or operation, so you know that the gradient of a function gives you the direction of steepest ascent. So basically, it's a direction where if I go epsilon in that direction, I can increase the value of my function. But we want to minimize its loss, okay? It's an error. So we actually go in the opposite direction. So we take the negative gradient direction, which is the direction of steepest decrease of the function. So what does it mean? That if the learning algorithm moves your parameters in that direction, then you start climbing down this function. And so if you just move your parameters in this direction, you can get a new program. And then you can start over the process again. You reevaluate the objective on the new program, you get a new gradient, negative, move in that direction, and eventually you hit the minimum, okay? And computing the gradient on all the data at each step, it's very stupid because you just need a few of them to get the right direction, okay? Getting the very precise direction at each step is just a waste of computing time. So what we do in practice is that we randomize. We just take a subset, we compute a gradient. This will not be perfect, but doesn't matter. We just iterate this process over multiple times. So we have what is called stochastic gradient descent, okay? And this is just the simplest learning algorithm that you can imagine. And despite being the simplest, it's actually also the one that's most used. But there are many other learning algorithms that have been developed, which is just an outcome of optimization theory. So this is just optimization, something that you learn during an optimization course. Okay. There is just one missing element. The programs that for segmentation have hundreds of millions up to billions of parameters, which means that this direction is a vector with 100 million entries, okay? And we have, those are just the parameters of the functions. Then you have the tensors that go through these functions. So the number of operations that you have to do, it's even larger, okay? So we need computational capabilities. And the biggest revolution has been when we started using the GPUs, which were created for computer games or computer graphics to actually do the computations. And not just one, but we need many of them, okay? And if the message was not clear, we need many of them, okay? So to train those models, we need a lot of computational power. That's also one of the reasons why the big companies actually got the largest achievements in the field because the poor university didn't have that computational power. They had the right minds, but not the computational power. That's why many professors now maybe have also a joint position in a big company, because then they can have a lot of computational power to actually do their researches, okay? So here is again an overview of the pipeline. I just talked about the segmentation, semantic segmentation part here. I don't know how much time is left to go over the rest, so I will just give a brief overview. But what I wanted to tell you is the importance of machine learning to solving some tasks. Of course, machine learning is not the solution for every problem. I mean, there are problems where the traditional, conventional strategy of the human trying to address the problem solving works well. I mean, if you have to sort an array, I mean, if you do it with machine learning, it's probably really not the right thing to do, okay? But there are tasks where there is not clear answer, where the patterns are so complex that your single brain is not able to find the solution there, where the brute force approach of the machines are actually able to solve the problem, okay? Okay, so one task was anonymization. Now, you can imagine that we have an ability of, for each pixel, finding out the category. We can find which pixels belong to license plate, which pixels belong to faces, and just blur that part. And so semantic segmentation gives you immediate access to anonymization. On top of this, we also created machine learning algorithms for recognizing traffic signs, which required another dataset. And we built another dataset for doing this. And so the mapillary vistas, the dataset for segmentation, and the one for traffic sign recognition are all open and available for the community. So if anyone wants to build his own model, he can go and have at least a dataset, okay? And we span 6 continents. And you can imagine that the same traffic sign in a different continent has a completely different appearance maybe, okay? So we actually have to classify 1,500, or at the moment we can classify 5,000 different traffic signs over 6 continents. Then we have 3D reconstruction. So I don't know if you did already a computer vision course, but the idea is that if you have images of the same scene, if you are able to find correspondences, so I know that one point here is the same point that I see from another view, and maybe you have more and more views, then you can start casting rays that will eventually intersect, and when they intersect, you know where the 3D point should be in space. Okay, so if you have enough views, enough constraints that basically tell you, okay, this point should be this point, and there are standard techniques for actually finding, or smart techniques of finding what is a potential correspondence. What you could do is you can set up an optimization problem again, where you want to find the position of the 3D points, given the correspondences, but you also want to know where the camera were, because you don't know where the camera is. So those are other parameters in the problem. And you cannot solve the problem in the right scale, because if I have images, I have plenty of possible scales of where the cameras are and where the points are that can actually provide you an answer. But we do have a GPS information. And with the GPS information, we can constrain the scale. So by having the GPS information, you solve this huge optimization problem of points, 3D points in the world, and the camera positions. And eventually, you can get the 3D reconstruction. Now, again, we don't solve a world scale optimization problem because it would be completely out of reach. We break the scenes into clusters. We solve each cluster, and then we have a hierarchical approach to actually, at the end, solve at the global level. And you also have to imagine that as we get new images, we need to keep updating this model. So those are not trivial tasks, okay? There is some complicated system in place to actually allow to get these updates. But at the end of the story, we get a 3D representation of the world. So we have a sparse point cloud, and since we have the segmentation, we can actually provide a semantic label to each point. Now, our goal, you should remind that our goal is to get those 3D features. We want to know where a traffic sign is, where a traffic light is. So once we have this 3D point cloud, we can start figuring out, okay, where in space the objects of interest are. And so we can basically extract map data in 3D space. So we can start, okay, now I found out that there is a traffic sign here, and I can have a database where I store this information. And this then can be used to access map data. Now you can imagine that I'm a city, okay, and I need to know where all my traffic lights are. Okay, just a stupid example. How can I do that? Well, I just take a car, go out, take pictures, or I ask my citizens if they can go out and take pictures. They will be uploaded on the Mapillary infrastructure, will be processed, and all of a sudden, you know where all the traffic lights are. So the city doesn't have to have a lot of funding to actually do all the process. They just need to collect the data, and we can process them we can process this data and give back the map data information that they could use for their needs. Okay? So the takeaway message is, first of all, for mapping, Unity is strength. Instead of having a single entity that does the mapping, it's better to have multiple people that have common interests in mapping who can jointly work towards getting data and get better maps. Okay? Plus, with this strategy, we can also get quicker updates. There is a disaster. People can go there, collect data. We can immediately make a map that can be used for getting quicker helps for that disaster area. And to get mapping at global scale, I mean, humans alone cannot do the job. We need machines. We need to process. We need automatic processes. And computer vision and machine learning are a key tool for actually getting this automatization for the problem of mapping. Finally, take away message for the machine learning part. For some tasks, it's better to focus on what we want to do and not on how we want to do, because finding how we want to do can be done automatically by the machine. Okay? So machine learning allows us to specify what we want to do. We collect the data. We show to the machine, this is what I want to achieve. But the job of finding what program can help you for solving the task, this is something that we can automatize. We can have a machine that searches for the actual program. Okay? Very last 2 slides. Okay, what are future directions? So I told you that we have this 3D representation, which are point clouds that we can eventually mesh. So we can just put some denser structure on top of this. But we can have programs, and when I wrote programs, what in the field we call them, it's neural network. And the deep neural network is just this stack of functions, just more functions stacked together. And this makes the deep neural network, okay? Because they build representations of that get deeper and deeper. That's why we have this deep neural network. But the nice thing is that we can use a neural network to represent directly a scene, okay? And once we do this, for instance, here we started with images of the church, and now we trained a neural network to represent the scene, okay? And you can see that we can now get dense representation of the scene that is geometrically consistent. Where it's blurrier is because we didn't have enough views of that part. We really took images around the church, okay? And now it's a neural network with their own parameters, okay? And the footprint of this, it's like 5 megabytes. While having all the point clouds and the meshes, you get 100 of megabytes. So it's much more compact and richer in terms of information that we can have. And now we can also make more interesting things. We can also embed semantics in the representation in a dense way. Now you see that there is a different color. This is semantic information. And when you have such a neural network, you can start rendering arbitrary views of the scene that you learned, okay? But this is not yet in place. I mean, we don't have neural representations on the platform. This is something that we are investigating now. What are the pros and cons of such a representation? how we can use it to improve what we have. So there's still a lot to be done, but this is one of the future directions we are trying to address. And yeah, sorry if I run over, but thanks.
So is there any question to our speaker? Yeah? There you go.
Thank you. There's a task that you can just make the picture less informative, and just take all the useful information, and then you dye it again for the purposes. Because this way, I think it's going to be much more less time consuming for computational.
Okay, so if I got the question. Why do we use RGB images and not black and white? Because we could reduce the computational overhead. Now, if you remember
and then paint it again.
Yes. So you see this program that I was showing. The input was at the moment a three-dimensional tensor. Okay. Because we have RGB, let's say we have three components on the color, and if I use scale grayscale, I would have a one-dimensional tensor in input. The next function, instead of 3 channels, provides you with 64 channels. And the next one provides you with 128 channels. Now, the time I saved going from 3 to 1 was epsilon with respect to the full computation. Mm-hmm. And it's more what you lose by removing that information rather than what you gain in terms of reduced computational complexity. So at the end, it's always better to retain information. Remember, every time, if you did information theory, every time you touch the data, you lose something, okay? You cannot get better, you just get at most. At most you get the same, mm-hmm. and you are lucky, or you get worse, okay? And so, okay, I hope.
And one thing is that you're doing actually supervised learning, but you don't have any picture of the thing that you wanted to get. How do you make that pictures? I mean, there is a real picture, and you wanted to make it somehow in the sense that you wanted to do something like a cartoon. Okay. But you don't have that images, so it's you cannot use supervised learning with it.
Okay, let me see if I got the question. We collect some training data, and of course we have some images there, right? And now at inference time, so we get other images, and the fact that the new images are different from the one I trained on, right? How can the algorithm still work? Is that the question, right?
No, it's like, for example, if we are going to label something, we need to know the actual label. Without that,
yes.
We cannot say the loss function or something like that.
Yeah, so this is supervised learning. We need to know in advance which are the relevant categories we want to label. And when we create the data set, we use those categories. And it's supervised learning because we are explicitly supervising the task. If we have a new class that we are interested in at the moment, we need to incorporate the new class in the data set. We need to increase the data set in order to solve the task. Okay? There are, in the field, techniques to be robust or still be able to recognize something when you have a new category. These programs have intermediate representations that can, imagine that you have one entry in this tensor, somewhere deeper in the network. One of those entries can capture abbreviation of cars, for instance. Okay? And maybe at some point you have a category which is zebra and horse, or at some point you might have you know, I don't know the English word, but the ones that is half a horse and half a human, okay? You will have somewhere in the deep structure that it can recognize the human part, can recognize the horse part. And now, if you want to add the class of this Sagittario, I don't know the English word, then you just need few additional labeled images, because the network, inside the network, there exists already a representation that can be combined together to get the new class. So what you can do is, you can start bootstrapping your new training with what you learned already, and try to just incorporate this new information. But the point is, it's semantic segmentation. The semantic doesn't exist without the human. It's something that we created as a representation. There are techniques to also learn in a self-supervised way. For instance, humans, if there is an object that moves, and it moves inconsistently with how I see the static part moving, I can imagine that that's something, no? And at the same time, in the same way, one can figure out, it's called self-supervised way. So basically, we exploit some geometric prior information to allow the machine learning algorithm or the model to figure out that there is something going on there. Still, I'm not able to tell you what's the object, because the semantics is something that I'm telling you. But maybe we can reduce the amount of additional data we need to tell the system, okay, that's actually, I don't know, a bird, okay? So this is just an epsilon part of the story. I wanted to show you what is machine learning and why it exists, and what's the benefit over conventional programming. But the field is huge, and I hope this is an incentive to go and attend the courses, because you will learn much more. I didn't tell you about the problems there, so it's not everything rose and flowers, if you want to say. So there are problems that a machine learning analyst or data analyst has to know to actually know how to train those models.
Thank you so much.
First of all, thank you for the presentation. I will switch for the business side a little bit. Wait a second for the mic. Yes, I would like to switch to the business side a little bit. And my main question is, what is the incentive for the people to keep uploading images? Because in the first place, you said, okay, we got people that started with 2,500 images, and okay, they were like the first pioneers of the whole project, but what's keep people uploading images? Like, how do you incentive them? Like gamification or whatever?
I mean, this is a perfect question. We asked ourselves the same. Just people liked collecting data. There were some crazy guys that alone were collecting millions of street-level data, and no one was paying them. Of course, so the company knew that it was important to keep users in the loop. So if a user was a great contributor, he was getting, you know, gifts like some mounting things where you could mount the mobile phone on the bike and go capturing, or they could become ambassadors. So they had this special, and there was community managers that were really trying to keep users happy for what they were doing, and they knew that what they were doing could benefit others. But we could also have users that they wanted to see their area mapped, you know, and that's they were just going out and capturing. Plus, there was also the possibility of having on their website, see the sequence of the capturing that they have done. So maybe someone was going out with a bike, and then we wanted to show the trail that they had covered. And so, you know, all these kind of mechanisms that were keeping users engaged. But it was not that we got a little from many users. Sometimes there were few users contributing a lot, okay? And I mean, they just liked it, and we don't have an answer. I guess a psychologist might be better to give an answer there.
Okay, thank you.
But I mean, it's a good question, because we were asking ourselves the same.
Maybe one last question.
Yes, I'm really interested to know if there are any optimization step during the recording step. I mean, if we like consider an average, we're sending something like 24 images per second to the server. And I mean, are there all useful? Like, can we remove some frames? And also, since our goal is to build a 3D map representation of the streets, do we care about all that 124 classes, for example, pedestrians and something like that? Because aren't we like wasting computational time and effort by identifying something that is not?
Yeah, so first of all, the reason why we identify them is because we need to know where dynamic objects are, because otherwise the 3D reconstruction algorithm will start making errors. Because it starts, you know, if you have a pedestrian that is standing, you get some capturing, and then it's just moving one step. This creates correspondences that are wrong. And I mean, the algorithm that does the reconstruction is robust to some extent. But still, if you can remove the source of noise from the beginning, it's better. So it was not, knowing where the pedestrian is or where a moving car is was not needed for the sake of getting 3D features or map features, but was needed for the sake of getting good reconstructions. Then on the question where all the data we need that was really needed, this is something we were starting discussing because we started having billions of images, and you know, we had a cloud service, and it had some costs, and these costs were growing crazily. Luckily, at some point, we got acquired, and the economical problem was gone. But we started reasoning. So first of all, the capture was not dense. On the app, you could decide every X meters. Then the users that were uploading, I mean, they had to spend time uploading that. So that was also an incentive not to capture huge videos. We were starting thinking about exploiting, for instance, the video compression algorithms. And instead of storing the images independently, start storing videos of the sequences. Because then you have the MPEG compression that can already reduce a lot of you know, repeated parts in the. But this is something that we started thinking about. Or also, for a very simple strategy, at some point when we have really a lot of coverage, start randomly forgetting images, stop uploading them. But it's a good question, and we were starting reasoning about this because we were really getting too much data, and we wanted to start focusing on where the relevant was. And other ideas were, since we could reconstruct areas, we could have a metric of how well an area is already reconstructed. So we could actually spend more computational and storage on areas where we are not, we didn't have data. Plus, we had also, we were setting up sort of competitions. If we knew that there was an area that was not captured, we were making a competition such that users had to go there and capture, and the best one then were getting some sort of gifts. Never monetary, but they were just doing it. Just showing that they had a ranking, they could be on the top, was just enough for them to go out and capture.
Thank you.
Let us thank our speaker again. Let's move on with the second part. Detailed description of the curricula, and then Professor Ercega will join us on Zoom to describe the internship program. Okay? So let us start with this overview of the curricula that you have in a data science program. So as you know, we have 4 different curricula. I will present the first 2, mathematics of data science and biological data analytics, and then Professor Ballan, next to me, will describe the details of the cognitive, social, and economic data analytics curriculum and machine learning and intelligent systems curriculum. Yeah? So, first a brief intro to the curricula. All the curricula we have are considered as a multidisciplinary platform, okay? And this platform should enable you to handle models and methods that come from statistics, machine learning, optimization, and of course to properly understand the way all these tools are intertwined in big data applications. Okay? Then you, as you know, you have plenty of projects and homework in the courses that allow you guys to develop project management and analytical skills. And finally, we have plenty of partnerships with industries and research institutions that allow you to implement mathematical techniques in the solution of really exciting data science applications. Right? Our courses can be roughly divided into 4 main areas. We have the ones related to mathematics and statistics. Then we have the ones related to computer science. We have the courses related to biology, economics, human and social science. And then you also have elective courses that can be taken freely taken in the all UniPD master's programs that we have. Okay? Let us start with mathematics of data science, MDS from now on. Okay? So as you all know, mathematics is basically ubiquitous in data science, and there is plenty of mathematical tools that are actually behind, as you have seen already in the previous presentation. There's plenty of mathematical tools behind data science models and methods. So mathematics really, and these mathematical tools make things work. Right? So for data science, the data scientist is very important to understand and, of course, develop new models and methods for dealing with those data. What about MDS? Okay, what I can surely tell you is that this program qualifies students to build and analyze structured models for the representation of concrete applications, to probably choose and develop methods for the handling of those models, and of course to get a deep understanding of some tailored techniques and some mathematical theory for the data analysis. And of course, what you also will learn to do is to combine and suitably redevelop all those tools in order to properly solve complex problems in practice. The courses that we have in MDS, they put an emphasis on notions that come from statistics, optimization, machine learning, and theory of big data representation. About what we expect from students. Of course, the students in this curriculum should have an interest in using mathematical tools and tailored algorithms for the analysis of data. And once the students graduate, they will surely have a deep knowledge of mathematical theory and the ability to deal with computational challenges behind data-driven problems. And so they will represent an effective and attractive professional profile that will surely find an excellent placement in the job market. And about job market, there are plenty of companies and research institutions that can be interested in such a data scientist, companies that deal with big data in finance, transportation and communications, and biology, and so on. Let's take a quick look at the curriculum. In the first year, what we have is a bunch of foundational courses and a couple of courses that are complementary, and they are really tailored to this curriculum. We start with the first part of statistical learning in the first semester and foundational information system. Then you have the option to choose between stochastic methods and high-dimensional probability for data science, and of course, machine and deep learning first part. In the second semester that just started, we have the second part of statistical learning, the second part of machine and deep learning, the optimization for data science course, and mathematical models and numerical methods for big data. In the second year, first semester, you will complete your exams with statistical methods for high-dimensional data, cognitive, behavioral, and social data. And then you have the option to choose one course in between these two lists. The first one, we have high-dimensional probability again, financial mathematics for data science, math cell biology, and structural bioinformatics. So there is a mixture between mathematics and biology and other stuff. And then one course in the computer science area. You have human data analytics, game theory, network science. And we complete the exam with the last elective course. Finally, in the second semester, you have the internship and your thesis. Okay? Let's switch now to BDA, biological data analytics. Of course, you all know that advances in omics technologies open new frontiers in biomedicine and biotechnology. And modern life science is really based on high throughput experiments. This is the reason why data scientists in this field need to handle data, need to be able to give data interpretation. And of course, this data interpretation requires computational technology and the knowledge of advanced mathematical tools. Okay? So what about BDA? It surely qualifies students to understand biological questions and to conceptualize biological phenomena, adopting this multidisciplinary approach that integrates mathematics, physical science, and computer science. The courses in this case are they focus on statistics and applied mathematics, machine learning, molecular and cell biology, computational biology, and bioinformatics. What we expect from students in this case is that they can tackle computational biology problems in a scientific, evidence-based manner. They can gain experience working through this multidisciplinary mindset, and of course, what I also expect is that they can effectively manage and exploit high-throughput experimental data. In this context, students will have the opportunity to perform real lab experiments and understand how molecular data are generated. Yeah? Also in this case, our graduates will have a good knowledge of life science and of course the ability to deal with omics data and to model molecular systems. And what we have is a profile that is effective and attractive also in this case that will surely guarantee an excellent placement in the job market again. About the companies, we have companies and research institutions in this case that deal with big data, but in biology and healthcare, drug design, precision medicine, and so on and so forth. The curriculum BDA is similar to the one we have seen before with respect to the foundational exams. The main difference now is that we only have machine learning, that is not machine and deep learning in this case. In the second semester, we start having the complementary courses, structural bioinformatics and intro to molecular biology. In the second year, first semester, we complete our exams with biological data, cognitive, behavioral, and social data. And of course, also in this case, we have two different lists of exams. The first one is related to biology and other stuff. We have systems biology, mathematical cell biology, and omics in human diseases. And the second list is related to the computer science area. In this case, we have deep learning, big data computing, and network science. And of course, again, we complete the list of exams with the last elective course. And in the second semester, again, we have our internship and the thesis. Right? Now I leave. And we'll keep going with the other.
Okay.
So thanks, Francesco. Okay, I'll switch a couple of things because I think that Samuel has already given a great introduction to some of the things that I wanted to highlight, especially at the beginning of the presentation. So the machine learning and intelligent systems track is probably the one that is close to, first of all, to systems. So to developing, to trying to develop final systems. So there is a, let's say, the hugest computer science component in all the curricula. So why this is interesting? So you already have great examples. I will not focus on the computer vision part because you already saw several things. But actually, you have also a lot of success stories that are probably familiar to you, such as machine translation, so more in general, the natural language processing area in which you want to develop systems that are heavily dependent on machine learning, deep learning models. Speech recognition, obviously visual recognition, computer vision, as we saw previously. So basically, the idea is that in this curricula, and this is not only, let's say, a prerogative of this, but here the focus is really on these complex, very interesting tasks in which you need to develop skills, core skills in machine learning tools and closed area. So what about then the machine learning intelligence system courses? Well, I'll spend a little bit more here because especially, I think later on we'll have also time to discuss offline if you want and also to take questions. But as you'll see in a few, in the next slides, the machine learning and intelligence system curricula is the one that is, let's say, more different from the previous one in terms, or at least we have the option to change a little bit the structure that you already saw in the first two examples. And so I will spend some time also to show you, let's say, the different choices that in some cases are not only, I mean, here we already designed, let's say, two major options, but actually as it happened several times, this is an option also in the other tracks. So let's use this as an example also to talk about, let's say, options that you have in all the, also in all the other curricula. So anyway, as I was saying, then the main difference with, especially with the mathematical track that shares several things, is that here we, let's say, we try to develop and to design a curriculum that is also, let's say, designed for students with a background in computer science and engineering. And so this is the reason why, this is not to say that only those students are taking this curricula, but the option that you have is designed to accommodate also those backgrounds. And so basically this means that especially for those students, you don't need to do again fundamental of information systems. This is probably the most important example. But you can also do it if you don't have this background. So as you see, let's keep this. So this is to say that then, this is basically open for everyone, but the computer science part here is stronger than in the other curricula. And so the students enrolled in this curriculum should have then an interest, first of all, on this, also on that, let's say, on this area. And so not only the mathematical tools, but also to try to design and to, let's say, develop also a strong understanding and skills also in the core computer science area, basically. Obviously, this is, you already had plenty of examples. People with strong backgrounds in technical backgrounds in this area are, there is a huge demand in basically any area, ranging from ICT, transportation, finance, biology, and so on. But anyway, so let's talk about the curriculum more in detail. As you can see here, and this is what I was referring to previously. So this is, let's say, our first standard option for this curricula, in which, as you can see, is the only case in which, especially the first semester that you already took, is basically the only case in which this is different. Because in this case, you don't have the fundamental information system course that, in this case, those 12 credits are instead allocated to cognition and computation and low-end data. Then in the second semester, and this is very similar to the mathematical curricula, Here you have, again, the second part of statistical learning and machine and deep learning. Then you have optimization for data science. And then you have a course that is knowledge and data mining. That is another course, mandatory course for this curricula in the, let's say, AI machine learning area. Actually, this is the only course in which you have also some examples or some tools from the more traditional knowledge representation-based AI area. So not only machine learning. Then you have an elective course. And then in the first semester of the second year, you have, and this is probably also as it happens in the previous cases, you have a cognitive, behavioral, and social data class, so in which you can apply machine learning ideas and tools to cognitive data, basically. Then you have an introductory course to computer vision and cognitive systems. So this is Samuel just gave you a huge and very cool intro to this area. And then you have another course that is again in the computer science area, in which you can pick one from big data computing, process mining, and information retrieval. As you can see here, and this is probably not super clear to everyone, at least in our experience. So as you can see here, you have the fundamental information system class, and this is the reason why you have this, I mean, that is here together with the elective course. You have this, I mean, this optional version, let's say, of the program, in which basically you can pick this course among, let's say, this pool of classes, in case your background is not from computer science or computer engineering. So basically, this is the thing that actually is not very clear, but it was the only option to us, so probably this is going to change in the future. But anyway, if you want to take this, and this is probably something that already happened, if you, I mean, if you want to do it, so sorry if I repeat things that maybe are already clear, but if your background is not strong, already strong on computer science, then what I already presented in the previous slide basically change again to the standard version that you already saw in the other programs. So basically, if you want to take the machine learning and intelligent system track, but I mean, you are graduated, I mean, your undergrad is in other fields, then you have to postpone the low-end data and cognition and computation class to the second year, and probably this is what you already did. Then the fundamental information systems class again is, let's say, scheduled for the first semester. I think hopefully this is clear. And then the final part, so the last semester, the second semester of the second year is the same as for all the other cases. So you have internship and thesis. Okay, so last but not least, cognitive, social, and economic data analytics track. Well, here, again, the standards, the structure is similar to the two previous one. But in this case, the emphasis, so again, is here the goal is to provide you strong foundations in mostly in cognitive in the cognitive science area, in which basically let's say the emphasis is on application coming from cognitive, social, behavioral data, and also economical data. And here, just to probably two examples are enough to understand what, two relevant examples are enough in order to understand what could be an application and why this is an area in which data scientists are playing a huge role. So if you remember, a few years ago, there was this huge thing happening around the Cambridge Analytica data scandal. There's also a Netflix documentary about it, in which this is an example in which machine learning, social media plays a huge role. But actually, most of the things that happen, in which basically Facebook, and then in this case Cambridge Analytica, was using data collected from a specific experiment coming from this small company at that time, can be used for user profiling. And obviously, this is also related to problems related to data, law, and stuff like that, and more in general, the impact of machine learning intelligence systems on society. And so again, in this case, having people with a background on psychology is really important to understand and to in this case, in a positive or negative way, to try to develop systems that can exploit behaviors, human behaviors, basically. So the main idea of this curriculum, in which you have a strong contribution from people from the psychology department, is to provide you also those skills in order to design systems that can exploit and take advantage of this knowledge. This is another example that actually is closer to the also to the computer vision machine learning area, in which again you have, this is an example in which, and this is a company that is trying to do user profiling on visual data, in which, for example, here you have another, you can see this as the output of a computer vision system, in which basically you have the results of models that are predicting emotions, or more in general, the user behaviors in a complex environment. Okay, why this is important? I already gave a couple of examples, but obviously here the, let's say, people, students that are taking this, this path are then strongly, they have strong, a strong background on both the technical, the technological aspects and tools, but also on the more in general, as I was saying previously, on the impact that this technology can have on society, especially from the cognitive science point of view. Then what we expect from students, in this case, very often there might be the case of people that come from those specific backgrounds. So maybe that people coming from the psychology department or economic statistics that are particularly interested in these applications. And in this case, let's skip this. Then, as you can see from the program, basically the first semester of the first year is the standard one, like in the mathematics and biology track. Then in the second semester, you can take, then you have in this case a mandatory course that is financial mathematics for data science, in which you'll see some applications, and also you'll gain some knowledge about financial mathematics. And then you have the mandatory course on optimization for data science, and one course in the computer science area, and you can pick between deep learning, human data analytics, or knowledge and data mining. Then the second semester, in this case, you can see from the colors that here almost everything besides the elective course come from the cognitive and economic area. So you have another mandatory course in business, in the economic area, let's say, so business, economic, and financial data. Then you have law and data, that is actually a class that is more or less mandatory or suggested or almost in every case, in every tracks. And then you have cognitive, behavior, and social data. Then the last optional course is between human-computer interaction, cognition and computation, and process mining. And then, as always, you have the opportunity to take an internship and then thesis. I think that's it. I don't know if you want.
I think we are good.
Do you want to come here or no?
No. I think this works too. So, guys, if you want to ask some questions related to the curricula, you feel free to start. Maybe the microphone. Who has the microphone? Yeah. Wait a second for the microphone so that we can, also from home, they can hear you.
I wanted to ask about the machine learning curriculum. For example, for people who don't select FIS, is it necessary, like those three courses are absolutely necessary? There was there in the list. Process mining, big data computing, and information retrieval on the next slide. Are these courses necessary, or they can change it for something else?
Okay, if I understand the question, actually, Francesco, you are in charge of the all the personal, yes, optional stuff. But yeah, I think I can take the.
You can
okay,
take
in
it.
general, the idea, and this is true for all the curriculum, that when in all the cases in which you have a pool of exams that are, like in this case, the number 11 is one course between, as you were asking, is one among process mining, big data computing, information retrieval. But, so this is, let's say, our suggestion, and this is, if you follow this, then you're fine, and your study plan is already okay. You don't need to ask anything to anyone. But there are I mean, even there are then for us, I mean, the complex cases in which also other things might be, let's say, less standard. But if you pick, if what you want to do is just to, let's say, I'm not interested in any of them, but I would like to, instead of doing process mining, big data, information retrieval, I would like to do, I don't know, whatever course you want from, like network science, for example. That is another course that is coming from another curricula. That is a computer science, I mean, it's a blue one, like this one. Then, but correct me if I'm wrong. It's not
well,
that I'm too, okay.
No,
okay.
guys, I mean, you can do that if there is a good reason why you want to do that. So in case you are coming from computer science, you already covered some of these exams in your undergrad path, then it's okay. Otherwise, you should give us a reason why you want to change that, because these are, I mean, these paths these curricula were created with a structure that we think is good enough, and of course, then you have 2 elective courses that allow you to choose freely choose other exams, also outside the data science program. So I guess there is enough freedom like that. And in case you have a good reason why you want to change also those ones, then you can discuss with the committee that is in charge of the study plans, of course. But this is, I mean, is might more complicated in this kind of process, because we have to take the committee has to take a look at the study plan that you propose and then decide based on what you say, the reason that you give, if this change is okay or not. Yeah. I hope this answer makes you happy enough.
Thank you. It's clear, just because we had a problem with information retrieval course, and I was thinking if it was possible to change it for something else,
okay.
Like natural language processing, because there's.
But do you have the free courses, the elective courses that you can use for that, for example?
No, but so one of the courses should be chosen from this one, like process mining, big data.
Yes, process mining, big data computing, and information retrieval.
But if
or fundamentals, but fundamentals is like if a person is not taking fundamentals.
Yes, if you do not take fundamentals, you have to pick one of those 3.
But if it,
unless there is a good reason why you don't want to pick one of those 3, but a good reason cannot be I don't like the courses. Yeah. Okay.
Yeah, probably I put this in the in the wrong way. Okay, so what I was
it's possible to discuss it. I mean, in case just this was the question.
But
so it's possible.
Yeah, exactly. So what I was trying to highlight is that if I mean, one thing is the fundamental. I mean, there is one topic that is related to fundamental information systems. So if you took this, then this blue disappeared. So the 6 credits that are mandatory in this pool of exams then are already covered partially by the foundational information systems. And actually also 6 credits from the elective courses are already covered if you are taking in this path the fundamental information systems. Of course, hopefully this is clear. This is the first topic, let's say. The second topic, and this is what Francesco was highlighting, is that, okay, then if we are not talking anymore about this, but we are in the, let's say, in the path in which you have to pick one among these 3. Then, in general, these are these are the mandatory courses, optional courses that you have to take. It's not but what I was trying to say is that it's not impossible, but this should be motivated, and this is going to be evaluated by a committee. You can take also another course, blue course, that is not among these 3. This is something that it can be done, it's possible, it should be motivated, and there are plenty of cases in which this makes sense, others in which it doesn't make sense, and so the committee eventually will say no. But it's impossible, but it's something that I say is possible. What it is impossible is to try to change one of these 3 optional courses with something that is from a different color, okay? So this is the meaning, and the same applies also for the number 12 in this case. When we say that you have to pick a course, and this is the same, let's stick on this particular curricula, but the same applies apply for all the other 3 cases. So if you have, in this case, one course coming from the purple, let's say, cluster, that in this case means bioinformatics, biological data, and business, economic, and financial data. Again, you are strongly suggesting you to pick one among these three. And the reason in this case is that you have one option coming from all the different application domains. So you have one in two actually, in biology, and one from the business. So you have the opportunities, depending on your interest, to select one of them. But again, if for some reasons you want to do something that is not covered by these three, again, you can ask to the committee. But in this case, you have to pick one course. It might be that you can take another exam that is not among these three, but in this case, should be a purple one. This is mandatory. So if you try to do something that is not following this structure, then the committee is going to say no. Not because it's not even evaluating this stuff. Probably you are not even considered by the committee, but for technical, administrative reasons, this is not going to be okay from an administrative point of view, because basically you don't have the requirements to cover all the different areas from a bureaucratic point of view. And the same applies. So this is something probably you are more familiar with me because you saw you are actually the one that is doing it.
Yes. But of course, my suggestion is in case you want to change some of the exams in a specific way, you better contact the committee first, and they will surely guide you in the choice, and you will be, able in the end to get a good study plan that fits you well. Okay. So my suggestion is, when you have some doubts about it, just contact the committee, and they will be ready to answer your questions. Okay.
Thank you.
You're welcome. Any other question or remark? Yeah? Yeah, microphone? Yeah. Or maybe there was one before you, and you have the next. So before, yes. You go on.
You said that we should contact the committee.
Yeah.
But is there an email address or something?
Sorry, is there?
An email address for the committee?
You're asking who's the contact?
Who is in charge of the committee, yes. Of the evaluation? So there is Professor, I guess you have on the website, Professor Marco Formentin and Professor Wolfgang Erb. And then, of course, you can ask me if you have a question, and I can always answer to your questions anytime you want. Okay? But the two professors in charge of the evaluation of the study plans are Marco Formentin and Professor Wolfgang Erb. Okay?
Thank you.
You're welcome.
Maybe the only thing that you can add, because this I think is a general suggestion, is that if you don't know, there is, in the website, hopefully there are most of the information that that you need in order to know who to contact. But if not, one first step is to write to the general data science at math UniPD email. So we have actually Laura or other people in charge in the teaching committee that are going to tell you who is the people.
Also about this, I want to add something. Of course, you can write, but since we have a big amount of email lately,
maybe so.
We organized also some Zoom meeting. So my suggestion is to join those meetings that the Secretariat organizes every month, I guess, or every 2 weeks, more or less, and join the meeting and ask as many questions as you want in those meetings. But it is much quicker, unless you have some deadlines or stuff like this. Then you can. It's better to write down an email and wait for the answer. Okay. Another question? Yes, that was
here in the first row.
My question is about the cognitive track, which, according to this plan, should have law and data as a compulsory course. However, when on UniWeb, at least, when trying to construct the study plan, law and data doesn't even appear as an option.
Because I can answer to that. Because I guess the cognitive. Can you put the Yeah, well. You say low-end data, you see, is in the first semester, second year, right? So since you are in the first year, right now, you filled in the study plan only for the first year. So the only courses that show up on the system should be the one in the first year, I guess, no? No?
No.
Okay, they changed it? Okay. And so low-end data should be there then. No, it's not there?
But what curriculum are you taking?
Cognitive.
The cognitive one.
It's, we will ask the Secretariat to check that, but it should be definitely there. So, okay, we will check it, and in case we will fix it as soon as possible. I mean, before the deadline of the submission. Okay. Any other question? Yes.
So every curriculum we have to choose 2 elective courses in 1 year. So can we choose 2 elective courses in, for example, in second year? Can I have?
Yeah. This can be done.
Okay. Thanks so much.
Yeah, here, I mean, depending in the different, okay, despite the specific curricula, here, as you can see, we put 1 elective course in the second semester and 1 in the first, but then, of the second year, but then obviously it depends on what is your choice. So there, those 12 credits are totally free. So you can really take whatever you want.
So
then obviously depending if you take, depending on your choices, maybe you pick 2 courses that are in the second semester. So you have to, I mean, so you have full freedom on that.
Okay, thanks so much.
Any other question or remark? So if there's not a question or remark, I would switch to the part related to the internship program, and then we can let Professor Ersege join us. Thanks that Professor unfortunately cannot be here because he's positive to COVID, unfortunately. But he was so kind and decided to join anyway from home. So welcome, Tommaso, and thanks for being here today with us. And you can start whenever you want.
Yeah, thanks, Francesco. I'm sorry for not being there. I would have liked to, but unfortunately I'm home, locked home. Okay, I'll try sharing my screen. Okay, works. Seems to work. Okay, so hello everybody. I actually don't see you, but we're gonna do the same. And my name is Tommaso Esseghe. I'm in charge of the internship. It's not only me. I'll tell you later on about this also. And today I'm gonna give a quick view about the internship process. You can find these slides and all the information in the data science website. So you have it in there under internships. So, well, just a very quick overview to start with, and then I'll try to give you some details which might be useful for you for taking your internship. So, of course, well, you know what the internship is for sure. Period of work orientation and training is not an employment relationship, so it's a short period where you essentially try to test your abilities and everything you learned during the data science master in a practical context. So it might be, as we will see later on, that you go to a company or to even a university lab or something like that. An important point with the internship is that it should be coherent with what you're doing during your master's degree program. That is, should be something somehow related to, I don't know, machine learning, big data processing, statistical data analysis, and also depending on the specific curriculum, specific path you're choosing in your master. So So this is standard for internship, and will allow you, as I was telling you before, to come into contact with the working environment and to somehow put into practice what you've learned. So you will develop new skills. It's in some sense an exam, so it's similar to a course, but it's different, and it's something that will help you somehow in your process of getting into work, which will be what you will be doing after the master degree. And work can be work in a company, but could also be work in the academia. So as Francesco and Lamberto were telling you before, typically when you have to do your internship, you will plan to do it at the second semester, second year. Of course, you have some freedom in choosing when taking the exams, and so you also have freedom in choosing when taking your internship. But the idea is that you have to put into practice what you've learned. So first you have to learn things, and then you can put those into practice. So the idea is second semester, second year. Formally, the internship is 15 credits, say exam, which is worth 375 hours. So formally, it's a 3 months full-time job. Okay, and typically you can combine it with your master degree thesis. You have 15 and 15 credits, which make 30 credits, which is 1 semester. So you do the internship and the thesis in the same place on the same subject, although this is not compulsory. You can also have them separate. So do the internship somewhere and the final project, so the thesis, somewhere else. This is also possible. Of course, in case you combine them, then you will have to somehow understand how to separate the work of that semester into thesis and internship. And what you typically do is that in the internship, you will include the most applicative part of what you're doing. I don't know, data collection might be programming, dealing with test cases, learning new things. This is anything that can be put inside your internship program. Where this is actually important because you can take your internship essentially everywhere. It can be in Italy, but it can also be abroad. Can be in a company, can be in a research center, can be in a university lab. So you have very many possibilities in the choice of your internship. So you might ask, how can I understand where to go for an internship? Well, there's essentially 2 ways. One is our contacts. So I'll tell you about this in a second. So we will give you some possibilities for internship. But of course, there's your contacts. Well, there's newspapers and there's the internet where you can get information and you can get availabilities from companies or research centers worldwide to promote an internship. So they're both valuable, and you should try to somehow exploit both ways. So what's our contacts? Well, the data science, the websites, the emails, and so on will provide you information about companies or research centers looking for interns. So that's one way. The other way is through the career service at UniPD. That's their internet website, where there's a list of companies that promote internships. And so you can go there, browse, and see if there's something that might interest you, and then contact the companies, of course, or the research centers. There's also an info day. Well, there's many, to be honest. Here I'm citing the Student Meet Companies Info Day, which is an info day for data scientists. There are others which, however, are a bit more general from university-wide, but you receive information about this from the data science emails, which is a day where selected companies and research center or universities are presenting their internship possibilities. So there you have contacts, and of course, there's faculty, instructors. You can ask faculty and instructors because they have contacts around for their research. So it might be that there is a possibility of an internship somewhere in some of in some of the contacts. So you have very many possibilities, and of course, your own contact as well. It has to be said, well, this is a bit bureaucracy, but still it's important to know that in order for an internship to start, then there might be somehow an agreement between where you go and the university. So all the contacts coming from data science, the career service, the student meet companies, info day, somehow already have the agreement. While if you find yourself a contact, then you will have to set up this agreement. But it's an easy thing that is done by the career service. So it's a lightweight, they say, accreditation procedure. It's simple and it's fast. But you have to know about this. I'll tell you a little bit more where to get information on this issue later on, because it might come useful at some point for you. Okay, this is the example of what we did on the last info day. The info day is typically in November. And okay, this is a list of companies and research centers promoting internships with data science students. Well, you can browse this later on in the slides available in the website. How to do? Well, this is a bit practical, but might come useful to you. So I would like to go through this a little bit, actually, with a little bit of detail in a second. And the idea, the general idea for the internship is that, okay, you're going somewhere to spend your period to put into practice what you've learned. So you need to find a company or research center, what the University of Padua calls it the receiving organization. And you need to identify a tutor there, which is put into contact with the university itself. But you will also need to find an academic supervisor, so a faculty here, who should monitor better what you're doing during the internship, and most importantly is in charge of signing documents, because without signing document you won't go anywhere. So keep in mind that you have to find out, okay, the company or research center, but also the academic supervisor. You will have to submit a training project, which is the description of what you will be doing during the internship. I'll give you details about it in a second. And then once the internship is done, then that's it. You will have your 15 credits approved. Actually, in case you take an internship, which is longer than 3 months, which might be possible, for example, if it's in connection with the degree thesis, typically might be of 6 months, then you can also have your credits approved after 3 months. So that somehow is done. One thing I actually forgot to say before, let me go back to here about the where, which is an important issue, is about Italy or abroad. Okay, there's no whatsoever problem in going to Italy, but there might be some problems in going abroad for those students that are here with the student visa permit. Okay, in that case, actually, if students apply to an internship which is in the Schengen area, then there's no difficulty in doing that. There's a time limit actually to be in the Schengen area, the career service and the international office can tell you about that precisely. But there might be difficulties instead if you're planning to go somewhere which is outside the Schengen area. I don't know if you're going to the US or the UK. In this case, well, it's not, well, you can still go for the internship, but know that you have to you are required for a specific visa to do that. So times might get longer. So you should somehow move in advance, plan in advance your internship, your period spent abroad, in order to be able to have all the data, all the documents, all the visas that are needed for that. So you have the possibility to go anywhere in the world. Well, in Italy, it's simpler because you already have a visa permit for Italy. It might be more longer or more difficult to get somewhere else. So somehow think about the internship well in advance in order to be able to meet all the visa criteria. Okay, what is in this slide instead is the contact. So who should I ask about internship? Well, of course, you can ask me. I'm the faculty responsible. You can ask Laura. She is the internship manager. You can contact them through the internship.datascience@mat.unipd.it email if you are asking things about internship. And there's also the career service at UniPD, so the central offices. They play a role in the submission process and in the paperwork, as I will tell you in a second. Actually, what I'm telling you in a second is a few detailed info which are available here in this website, which is the data science information space, to which you can see by logging in with your UniPD credentials. You all have UniPD credentials, so that's where the next information is coming from. Okay, so what comes next? Full guide. I named it, but I'm gonna be quick about this. Is a few interesting aspects that you have to consider for the internship. Well, possibly you will not be considering them now, but you will be considering them later on. But it's important that you hear about them once in order to have them in the year and be able to understand what to do. So, paperwork to start. Well, very first, general information. Informations about internships are available in the UniPD website, unipd/n/internship. That's the English web pages. You find everything there. So all you can ask possibly is written in there. Also take into account for reading the Italian pages, which is this .stage website, because sometimes they have a little bit more detailed information than the English website. And you can use Google Translate for that or your colleagues. So keep in mind also to browse those pages in case you don't find the information you're looking for in the English pages. Okay, we already talked about where to go. This is a snapshot of where students have gone in the last 2 years or so, maybe a little bit less than that. So you see, well, I've been naming those as PD, labeling those as PD if it's around Padova, IT if it's somewhere else in Italy, or you have the nation labeled there. So very many possibilities. Well, you could use this list, plus obviously the presenters which we have today from Meta, Intuendi, and ahead as a starting possibilities for getting an internship. Here I also have some interesting data about the choices of students. Well, this is from statistics from 1920, so it's a bit old, but we don't have the updated statistics so far, but should be similar. Should be similar in the sense that people have gone mostly on Italy, 60% and 40% abroad. So very many students have gone abroad. And this percentage might increase in future because of the end of the pandemic. One interesting aspect is about this. Did you receive a job offer? Actually, 66% of students did receive a job offer from the place where they did get an internship. And 66% is a lot, also because remember that there's a student who do their internship at the university premises, so you can also do it at the university premises, but you will not receive a job offer from the university. You have to apply for a PhD or for a grant, which is different from a job offer. So this means that essentially there's a very, very high chance for you to get directly into the job market by doing your internship. So it's important, it's fundamental that when you choose what to do in your internship, then you choose it wisely. And this somehow links us to the satisfaction about the internship. This is student satisfaction. So note that most of the students, well, this is from 1920, but I believe it will be similar in later years and similar through also the other master degrees. Most students are very satisfied about the internship. No one is giving 10 out of 10 as a satisfaction because, of course, you are very good students and you're looking for the top possibilities for you. So any possibility won't be 10 out of 10, will be 9 out of 10, but not 10 out of 10. But still, this means that that students were satisfied. But still, there's a small percentage of students that they were not totally satisfied by the internship, which is natural, but it's something that you have to keep in mind because you should not accept any internship that comes. You should accept an internship only if it meets your expectation. So for an internship, you will be interviewed, but please try also somehow to interview the company or the research center in yourself to understand what they're really offering. If what they're offering meets your expectation, and if it does not, then don't go for that internship because there's a wide offer out there. So you will have the chance to look around and find an internship that really meets your expectation. And this is very important. And if you want, this is part of the internship exam. This is the very first thing that you should do. Try to find out a good internship that meets your expectation. And you will certainly be able to do it. So that's it for choosing an internship. The other thing, as I told you, you have to do is choose an academic supervisor. And the idea is that, okay, it should be an instructor or faculty here, but mainly should be someone who knows about what you're doing in the internship. So somehow she or he must be knowledgeable about the main topic of your internship. Sometimes so in this case, you should contact the instructors you met during the course, during the master. If you don't find anyone there, then there's me. I can play the role of the academic supervisor in any case. So you're safe in a sense, but I can't do the academic supervisor for everyone. So try finding an instructor or faculty that is interested in your internship and is interested in being your academic supervisor. okay, there's a postscriptum here which might be useful later on, but you can read by yourself. There's actually, once you've found your internship, so the receiving organization and the academic supervisor, then you have to somehow formalize the internship. And to do that, unfortunately, you have to attend a safety course. This is what you have to do. It's a 4-hour simple course, general training. I put the picture here because the website is in Italian, so some of you might find it difficult to locate it, but then it's something simple. And one thing you have to know, if you've already had an internship with UniPD, that possibly you already done this course, you don't have to do it twice. You only have to complete it once. And then the other thing that you have to do is, this is important, as I told you before, is get an agreement with the receiving organization of the internship. Actually, I'll tell you in a second how to understand if there's already an agreement or agreement is not in place with UniPD. But if it's not in place, then the place to get information on how to sign the agreement with UniPD is here in the internship web pages of the UniPD website under Activate Internship, either in Italy or abroad. There are slightly different processes, but you can find all the relevant information there. And once you have the agreement, then you can submit your training project. And actually, you can submit it through this website, careersunipd.it/English. If you're possibly going for the English website, you should select training project, and you should select a compulsory training with credits, because yours is a compulsory training. And it also has 15 credits associated with it. What you have to write in the training project is how the internship is organized. So the duration, the activities, who's the receiving organization, who's the receiving organization tutor, who's the academic supervisor. And actually from this website, you can actually check on whether the receiving organization is or is not in the UniPD database. So you check through here, and if it's not, then you go back to those web pages I was referring to before. Okay, in here you also have to put the date of completion of the safety course, so you have to attend it and then check if you did attend it. One important aspect, I'm almost done, is can I get paid? Yes, you can get paid during the internship, but this is something you have to contract with the receiving organization and something you have to put in the training project. So keep this in mind. Typically, internships are either paid or reimbursed. So you can ask for this, the receiving organization for this. And then you have to submit. This is to remind you that submission of the training project should be done by sending it to this email, stage@unipd.it. And one important thing to know about is that signing the training project means electronical signing it. So the academic supervisor will not have any problem, nor the receiving organization, but in case the receiving organization does not have an electronic signature for any reason, then there's a way out. You simply have to contact Stage at unipd.it, and they'll solve the issue for you. So remember this, because this is a novelty. The electronic signature is something which came into place this month. There's an alternative to internship, which is Erasmus Plus traineeship, which is similar. It's, if you want, the Erasmus Plus, but for traineeship, so for internship all around, say, Europe. and it's a paid alternative that pays slightly more than Erasmus Plus. Well, it depends on your income, but typically it might be around 600, 700 euros per month. One important thing, well, two important things to know is that if you do Erasmus, so if you go abroad for a period, spend a period abroad and do exams there, then still you can spend another period abroad for your traineeship, so for your internship. So they're not exclusive. And the other thing, which is interesting to know, is that you're paid through the Erasmus Plus traineeship, but you can also get salary from the receiving organization, unless it is part of the EU organization. Because EU is already paying you through the Erasmus traineeship, so they don't pay you twice. But you can also get salary, which might be important for you for living abroad for a period. There's an open call, obviously, for this, with two deadlines in July and September. These are the last year deadlines, but new deadlines will come out soon. Actually, if you're applying to Erasmus, then you should forget about most of what we have talked before, because it's a different process. You have to read the documentation, and here you have all the information available in that website. Okay, well, during the internship, what you do? Well, you do your internship, but stay in contact with us. And us is obviously mainly your university tutor, but also me, Laura, and the UniPD Career Service, all depending on what the issue is, but mainly with your university tutor, because she or he is in charge of taking into account that the internship is proceeding in the best possible way. So give feedback to the university tutor. Once you come back, then it's simple. You've already done the internship. There's simple paperwork to do, but somehow important. The first thing we ask you is to prepare a short report, summarizing what you've done, but also summarizing somehow how do you perceive the internship. So the type of working or environment conditions that you have experienced at the receiving organization, and any critical situation that you might have faced. Critical, might be with us, might be with the career office, might be with the receiving organization. It's important if you give these feedback to us, because we will be able to steer somehow what we do with internship and to be able to solve problems if some problems arise. Obviously, we hope they will not arise, but might be the case. So it's important to receive feedback from you. And then you have to assign, well, to fill an internship completion certificate, simply something simple or, well, simple that should be signed electronically by the receiving organization. And then send everything to stage@unipd.it. And this is a novelty that we're putting into place now, is that once you send this, then we will be automatically recording your 15 ACTS credits in a few business weeks. We have still to do this automatic process, start doing this automatic process. So we hope we will be able to do this in a very, very short time, but we'll have to somehow understand how to manage to do it quickly, but we'll do it as quick as we possibly can. So essentially, it's very easy for you once you come back to get your credits recorded. We simply need a signature from the receiving organization. And that's it for internship. Here you have some additional links to the UniPD Careers app might come useful, or the Facebook website that might also come useful. And of course, I'm here for questions, whatever question you would like you would like to ask. Okay.
Thank you, Tommaso. And is there any question related to the internship program that you would like to ask to Professor Ersege? No questions? Well, there will be time for questions, I'm pretty sure about it. So I would say we can then stop here, and thanks again, Tommaso. And I will give him an applause.
And thanks to you.
And so this first part of our meeting is officially closed. And we have a lunch break now, and then there is also the guided tour of the Orto Botanico if you want to take it. So see you in a couple of hours, okay? Enjoy. Bye-bye.
Okay. Thank you, everybody, for coming back. We are ready to start the afternoon section, and we are safe from a storm that is arriving right now. And the afternoon section, we start with Federica Picca Nicolino, from Intuendi, a startup in Florence, if I understand. Okay, thank you.
Thank you. Thank you. Sorry, there's something to change the slides. Do I have to use the keyboard?
Okay, no, there is a, okay, yeah.
Oh, yes, thank you. Okay, good afternoon, everyone. Sorry. Good afternoon, everyone. I'm Federica, and I'm here to talk to you about who I am, my job, and data science as a job opportunity. And I would like to thank Professor Rinaldi, who invited me as a person from Intuendi, since we are a very young startup, and it's also a nice opportunity to show the company to you, which are the future for the company, probably. And today, I would like to talk to you about my company, my job, who I am, since I want to show you a different job opportunity, probably, I don't know, and see this kind of opportunity from a data science, let me say, from a different point of view and perspective. So I will start talking a little bit about me. It's a little bit selfish, sorry. And, but this is intended to make you understand why I then choose to do what I'm doing. I studied mathematics, so I have a degree in mathematics, and at first I wanted to become a teacher because I like to stay with people, to teach science, let me say, and this was my goal at the beginning. Then I discovered that this wasn't for me, okay, because I didn't like schools. I have been in some classrooms to teach something, and it wasn't for me at all. That's why I decided to move to applied mathematics, and I did my PhD in operations research. And I found that operations research was really beautiful and so applied. And I decided that could be my job, okay? That's why I then became an operations research analyst in a company for public transport. But doing that, I realized that, okay, it was really beautiful, but I spent my entire days behind the screen, talking only with my colleagues of the operations research group. And then I decided that I wanted something more social. I wanted to interact with people, something a little bit different. And that's why I became an implementation specialist at Intuendi, that is my current company. This is a slide about data science and me, because at the beginning, as I told you, I wanted to become a teacher, and I thought about data science like something, a very scientific discipline, so something that was more similar to academic research, something very theoretical, and it's not. Probably you know better than me, because you're studying so many interesting applications. I've seen Samuel's presentation this morning, was very interesting. And seeing the data science as a scientific discipline, I was thinking that it was something like data analysis all day long and laptop-only relationship, and I didn't want something like that. So the subject was very interesting for me. I loved that, but I didn't want this kind of job every day of my life. I was thinking that, okay, this cannot be my job until I will be 60, or probably later, almost surely later. And that's why I decided to move and become an implementation specialist. That it's something that I will describe to those who didn't know what it is, like data science through human interaction. Since an implementation specialist is a person who provide customer solutions, guidance, and also want to share knowledge, want to share process flows, and I will tell you later how we do that in Intuendi, and also related to what we provide to our customer, okay? And so, this is my company. Intuendi is a young startup in Florence, and if someone, I've seen that you can do an internship. If someone wants to join us, you can just look for intuendi.com on the web. We'll be pleased to have one of you. What we do is to provide our customer a software for demand planning. It's an application probably a little bit different from the one you have seen. I've seen a lot of, for example, computer vision applications or deep machine learning applications. And this is a little bit different because we work with industries or companies which sells goods. Okay, so industries which sells, for example, shoes, shorts, but also wines, wheels, many different things, but they are goods, okay? So it's a little bit different, for example, from what Samuel's presented this morning. It's more, in my mind, it's more practical. You can touch by hand what your customers are doing, okay? And demand planning is a quite challenging process for companies and for industries because it can be very complex. There are many constraints, and the thing that is most difficult, I think, is that each company sees its process as a unique process. They are not able to model the process to see it as a more general thing, okay? And to make you understand better what I'm talking about, I have summarized here the 3 main steps of the demand planning process. I don't know if you are familiar with this kind of themes, so I decided to introduce them. And it's a flow, okay, that models the company's work. Imagine that you have a company that, for example, sells shoes, as I told you before, and what you need to do is to forecast how many shoes you will sell in the next month or 6 months in advance. I don't know, it depends on you. And so you need to forecast the demand of your goods. Then, to be sure you can satisfy this kind of demand, you will need an optimized inventory management and optimized replenishments. So you need to have a process that optimizes the quantities that you need to have in stock, okay, in order to satisfy the demand from your customers, but you don't want to have too many items in the warehouse because otherwise it will cost you, okay? And there are many constraints usually related to quantities to have in stock, but also to suppliers that are the ones that you buy your goods from. Okay? So for example, the producer of your shoes. And one other complex thing is that you can forecast that, for example, in the next month, you will sell 20 pairs of shoes, for example, but your supplier takes 6 months to give you those 20 pairs of shoes. And so you have to do all this process in advance. So this is something about demand planning. So it's a supply chain management process that usually needs to be optimized and modeled also. As I told you before, many of our customers think that they are managing a unique process because they have constraints that are tailored on their business. But this is not what usually happens. Usually our customers have all the same problems, okay? So as an implementation specialist, that is my job, in my work, I help our customers to understand which are their needs, because often they don't know what they need, and to model the needs into problems, okay, let me say standard problems, and I also try to guide them into our process flow of the software we produce, and also to share with them some knowledge about demand planning process so that they can also understand that they're not the only ones who have this kind of problems, okay? That everything can be inserted in a sort of common schema that is valid for everyone. But, as I told you before, I didn't want to spend all my day just saying behind my laptop, writing lines of codes or modeling things and something like that. I also have the chance to have relationship with our customer. So it's something different probably from the work one can imagine coming from data science or talking about data science. And I liked it because it allows me to have relationships and also to know new people and new countries, new cultures. We have customers from all over the world, so it's very interesting for us also to learn something new about cultures and people. And it's an opportunity for me to that lets me to follow my natural inclination to socialization. I don't like to stay in a room alone to write. This COVID situation has been hard for every one of us, and everyone has been probably alone in his room, working alone. And this was my previous job, so today I'm happier to have some relations with other people. And also this kind of job allowed me to be here today, for example. Okay, I think it's a very interesting opportunity for all of us. And what else? As I told you, to be an implementation specialist in Intuendi is very related to the fact that we produce a software for demand planning process to optimize it, and to model common problems, okay? Which could be the common problems that our customers can face. This is the most related part to data science, since you are going to choose your path, your curriculum during the next year. Related to the 3 phases of the demand planning process, there are many different problems that can be faced. For example, for what regards the demand forecasting problem part, let me say, the first thing that they have to face, usually our customers ask us something to have a more accurate forecast, okay? So they want to know in advance how many things should be sold in the future, but they want to be more accurate as possible, okay? For example, if you sell jewels, okay, gold jewels, silver jewels, your goods can be very expensive, and so you need to know how many things you will sell, because you don't want to have so many things locked in your warehouse. It's very costly. And for example, another problem that many of them are facing, it's the problem of new product forecasting. If you want to sell something new, it can be something completely new in the whole market. It can be something new, for example, only for Europe. If you maybe just already sells things in the US and you are moving to Europe, it can be very different because tastes of people can be very different. And they need to understand what can be used, extracted from the data they already have about the US, and that can be exploited again in Europe, for example. For what regards instead the part of the optimized inventory management, the main problems are the one of stockouts, so have no stock so as to satisfy sales coming from customers, and this is a real big problem because you lose money without selling anything. And the opposite problem, that is the one related to the excess of stock. So you don't want to have many items locked in the warehouse because it's costly too. Instead, for what regard optimized replenishments, you need to understand when order your goods from your supplier, and you want to have those goods at the right moment in your warehouse. And all of these things should be inserted in a sort of optimization of budget, because you don't have always the money you would like to spend to buy new goods, okay? And nowadays, another important thing is the fact that logistics is becoming more and more expensive. So many of our customers are, for example, asking for something that let them use as less containers as possible to make goods move from, for example, maybe Asia or China and come to Europe, or to Asia, from Asia to America, or something like that. As you can see, you have read some words that probably are very familiar to you, like the forecast, optimization, and something like that, because these are all the problems that are presented to us, saying, but I have this problem, I want to know. We try to model them and to insert them in one of these, let me say, container, okay? So the container of the forecast accuracy, or the new product forecasting, and so on. And what we can do to help them, we model them and solve them using mathematical tools, let me say. And this is where data science acts, okay? As I told you before, I like to be in contact with our customers, to have relationship and something like that, but at the same time, I'm working in the R&D department of my company, and it's where we think about how to solve all these problems. We have modeled them all together, and then we find a way, a solution for them, okay? Without giving our customers tailored solution, okay? We don't want them to find the solution only for their problem. We want to find a solution for all of the problems that can be classified, let me say, like them. And okay, this is what we do. So, for example, as I told you before, we have talked about demo forecasting that can be done with a deep knowledge of statistical time series forecasting, for example. And then we have new product forecasting that, for example, can be done having a good knowledge of machine learning and artificial intelligence in general. We usually create clusters of items, for example, so clustering methods, something like that. We also use machine learning usually to identify potential outliers in the time series the customers are giving us. And my first love, operations research. Okay, as you may have seen, we have problems of excess of stock and stock outs, which are problems that can be easily modeled using mathematical modeling and solved using operations research techniques and algorithms, and also problems related to the optimized replenishments. As I told you, there were budget constraints and also constraints related to the cost of logistics that can be easily modeled and solved with operations technique. And this is where we use what you are going to study. And what I wanted to do today is to show you a data science, or I've seen many interesting exams that you can do, that you can have, and they can be exploited once you will be in the world of jobs in a different manner. And I don't know if you want to be a pure scientist or not. This was not what I wanted to be, and this kind of job gave me the opportunity to be something in the middle, let me say, from a social point of view and a scientific point of view. Nonetheless, I need to be very skilled in this kind of things to be sure that we can provide solutions and models to our customer to be also confident with our software, that it's very important for us, okay? And that's it. I've been, I think, a little bit short. But I didn't want to have a too technical talk for you, because I've seen that probably both in the past events and in the next you will have many. And I don't know if there are any questions or something like that, or any Curiosity. Okay.
No, okay. There is any question? Comment? Perfect. Really no questions about.
It was like,
after lunch,
like
yeah.
I got a chat with everyone.
No, I thank you very much for your exposition. Okay, and thank you again.
So we have now a short session, let's say, with following in part what you already saw in the previous talk. The idea is to give you also some experiences and to see in particular now what other of your, let's say, former colleagues or people that are at least at the end of their path in data science, what they are doing, what they did. So we have 3 invited speakers, and so please all come here. And so we have Derek. I don't know if there is already an order or we can decide now. No, it's up to us. This is going to be a bit informal, so I think we can stay all here, right? So the 3 of them. Okay, let's do the, so we have Derek, Veronica, and Alberto. And so this is really up to you. Maybe we can start with Derek. If it's fun, let's go in the nearest neighbor. So let's start with Derek.
There's my face.
Oh, yeah, here we are. Cool. So first of all, thanks for being here with us. And yeah, let's try to do this in a very informal way. So if you have questions or any doubts about what they did, what are also the, let's say, the good and maybe the not so good thing that happened over the path. So that's the opportunity to you to discuss also about that. Okay?
Thank you. So Professor Rinaldi emailed me a few weeks ago asking if I wanted to talk about myself. I got really excited, not only because I love talking about myself, but also because this is actually the first time I've presented in front of people since COVID. So it's actually very exciting for me. In my previous work life, I worked for 10 years in the advertising industry. And I did a lot of presentations during those times. So this is something I'm thrilled to be able to do. But you'll see it's also kind of the reason I'm here, because how my career went. So I graduated a little bit longer ago than probably most of you did. I did my undergrad ending in 2012. During that time, during my work experience, I started gravitating towards programming. I found an opportunity with my now wife's family business to be able to build apps for a haunted house, which I'll talk about in a little bit. But it kind of pushed me into this category of realizing that I wanted to become more technical, because my degree was just in marketing. And while it was interesting, and I still absolutely love the category, I found myself more stimulated by programming and mathematics, so I gravitated to a role as the vice president of analytics at the agency I was working at. So now here I am. My path is actually in the machine learning path, so any of you guys doing that, I'm more than happy to give you some of my experiences there. But I come from the United States. So I come from Michigan, so if you're from Michigan, you typically explain where you are using your hand because it looks like a mitten, so I always will point and I say I'm from Detroit, Michigan, right? I've been trying to get Italians to kind of do the same thing, but it doesn't seem to be catching on very much. Like, I'm not sure why, but I decided to move to Padova. The reality behind it, though, was I was burnt out from work. I was traveling constantly, about 3 different cities a week, pitching very similar things: forecasting, media mix modeling, multi-touch attribution, a lot of that kind of stuff. And I needed a break. I needed to shift, and I needed proof on paper that I had a more technical capability. So I moved to Padova. Why? Actually, my wife is a dual citizen. She doesn't know Italian, though, which is really kind of funny. So we ended up coming here. School's actually very affordable compared to the United States, and the quality of education is identical. So it was a win-win, and I got to travel around Europe, so I thought, and then COVID hit. So I'm trying to make the best of it now, but I said, before I quit this awesome job that I have, I gotta make sure I do 3 things, or 4 things. 1, get that piece of paper. 2, I didn't want to be client-facing anymore. I wanted to be more product and engineering side, so that's really a big reason why I came. And it was a weird thing. I just really wanted to get published, to like almost go 1 step further. And then the last one is travel the world. So talk a little bit about my experience, and Ferrante may have scarred me at the very beginning of this. First day of class I came in, it started off very rocky. Okay, my high school experience ended in 2008. That was the last math class I took. That was 12 years since I had taken a math class. And he comes up on a chalkboard day 1, starts writing what I thought were hieroglyphics on the board. I didn't even know what those symbols were. So I come from a very weird background where this just didn't make a whole lot of sense. But also, you know, the COVID thing also made it quite difficult to get here, and I'm sure a lot of you have experienced the same thing. And that's exactly what I was just saying. And then also I was like, oh, I know how to program. I taught myself how to do this, and I got into phys, and I failed the midterm. And I'm sitting here going, how did I get into this program? Why did they invite me here? But honestly, things turned around quite quickly. I passed stochastic methods on the first attempt. Woo! That was... I landed a paid internship at a tech startup, which has been my dream forever. And how I got this was really funny. So I was helping my wife and her family with a haunted house business. For those who are not familiar with it, it's essentially a huge thing in the United States where people pay to get scared. Very weird. I'm not sure why they do it. That's actually the first date I ever went on. My wife invited me to the haunted house, and I'm like, I don't like getting scared, but I did it anyways. So why am I talking about this? Well, COVID hit, and they needed to find a way to essentially manage lines, but social distance. And thousands of people come to this park in a given night, up to 5,000 in one night, and it's only open for a few hours. So they had to find a way to do it, and we found a company called Waitwhile. And this company essentially just texts you. You get into a virtual line, and they text you when it's your turn to go through the attractions to get scared. And that was what we had set up, but their wait time estimation was just horrid, absolutely horrible. So I'll talk a little bit about that in a bit, but that's how I ended up getting my first tech job, is I emailed them saying I can improve your product. They hired me permanently. Now they've hired me as the head of data at Waitwhile, which is a very funny title. I'm not exactly sure what it means yet. They're letting me work part-time until I graduate. So. And sure enough, I am attempting to get work published, and I didn't even really try to do that, but Professor Rossi in the human data class liked our project Emanuele and I were working on, and we've attempted to publish that. So I'm going to talk about some of these things here, but also I learned a lot. So this is Waitwhile. This is the app. This is the interface. The line is virtual, and the employees check when people come in, and essentially it keeps track through their phones. They get text messages. I kind of told most of this story, but I did email the CEO, essentially, and he hired me right on the spot, which is, I guess my advice on that one is don't be afraid to email someone if you have a really good idea, because you never know what's going to happen. But essentially what I've done in this job is I've converted what was a mechanical-based model into a machine learning-based algorithm. They were essentially just saying each person that's in line has an average serve time of 15 minutes, and let's just add every 15 minutes times the number of people in line, and they were just kind of brute forcing their way through it. I'm just using, really honestly, basic machine learning algorithms, XGBoost, multi-layer perceptrons, et cetera, and testing which ones can create the best predictions of wait times. Tons of data. I mean, more data than I can even handle at this point, but it's really awesome. They work with big clients like IKEA, in the United States, Applebee's, Best Buy, Louis Vuitton, a lot of these kind of companies. So that's kind of my experience there. It's been really cool, and it's ever evolving, but I'm also writing my thesis on this topic as well. So it's currently in progress, but the biggest things I'm working on were those wait time models I was telling you about. I'm actually, it's not too crazy, but I've built an asymmetric loss function that can penalize under predicted wait times, because no one likes to be told you're going to wait 15 minutes and you had to wait an hour. You would prefer the reverse. You'd rather be told you're going to wait an hour. So I'm penalizing those under predictions in the models. So that's kind of one of the contributions. And then something they are not super happy with, because the train time, the costs, and also the prediction times, I'm trying to build more of a temporal-based model to make these predictions, where you're taking the state of the line, all 100 people, and all of the various attributes about those people that are in line at one given time. 100's probably a lot, but you get my point. And I'm trying to make predictions off of that using LSTMs or temporal convolutional networks. It works really well. They don't necessarily like it for production purposes because it's very heavy, and they don't want to call an endpoint. So that's just more thesis-based. It was just for my fun. But then also, because they wanted to be so lightweight, I actually built a compression-based model. So XGBoost was their favorite, but the model file sizes were really big, and they needed to store them under 1 megabyte. So I had to find a way to compress, but I didn't want to have to unzip and read the file in every time. So I built a compression, really basic compression of the model file sizes, and built inside Node.js a predictor that reads the compressed format. So you don't actually have to unzip these model files to make the predictions, making the file size extremely small compared to what it normally exports as. So that's really what I did throughout this internship, and that's what I'm writing in my thesis. And then the paper submission, this was completely unrelated. I worked with Emanuele Zangrado on this, and the dude's like a super genius, so I'm not going to take complete credit for this. But we had worked through applying adversarial attacks to audio, because there's a ton of research in the image space. But in the audio space, it does exist, but we couldn't find a lot of research around techniques of kind of mitigating and making your models more robust to adversarial noise. So we applied it to, we essentially applied it to the sound classification data set, and had a white noise attack that used essentially just the gradient of the loss as a way to generate the noise. That noise then, if you apply it to the audio, will hone in on making sure that you're misclassifying them at that point. And we applied what we called, it was just like an alpha score to increase the amount of noise, and at what point did the adversarial noise cause a misclassification. And we normalized that and compared it to a non-noise based approach. And the distance between the amount of noise and the base model was actually how we compared robustness. But you can see the final architecture we used had 5 components: Gaussian noise, random translation, time frequency masking, spatial dropout. If you're not familiar with that, it's essentially doing dropout of the entire convolutional filter rather than pieces. And then a denoising autoencoder at the beginning, essentially with a residual skip connection of the same exact input into the model. So you're essentially concatenating a denoised version of the audio and the actual audio itself. We did that so that the original audio, if it was clean, was still coming through, but then the denoising, if it was perturbed, we were able to reclassify and push it back through, and both of those helped improve. The results were interesting. The bottom one is the combined of all of those methods I just listed. The RMT is kind of a weird made-up thing that we did that essentially says anything above 0. If it's 0, it's going to be just as robust as as the base MelNet model, which was just a basic neural network. And each of those were the techniques that were applied. And the higher the number, the more robust it was to noise, essentially, adversarial attack specifically. So combining all 5 methods was immensely better. And it's just architectural decisions that helped improve robustness. So. And final note is I did most of what I came here to do, so I'm quite happy about that. And I'm still working on the last check because I'm working on my thesis literally as we speak. But right now I'm traveling quite a bit, and I'm really excited kind of to finish up here. So just quick parting advice. I felt like an imposter, if you guys do too. Honestly, just keep pushing through. You're going to be amazed what you guys learn, and you'll find your own special category and places where you can be in this program. Embrace discomfort. It's extremely important. It's very good. My colleagues helped me get me out of the math issues here because it was a big hurdle. And definitely rely on your colleagues and try to find someone that has a different background than you. Don't put off taking exams. That's one thing. Everyone's like, oh, I'll just not take it right away. Just do it. Okay, if you fail, who cares? I mean, you get to take it again. So just take every exam right off the bat, then you know what to expect. And then find your passion. Scarefest, which is the haunted house, was kind of my passion, and I used it whenever I could in my projects, and I used it to kind of latch on and try to learn with more context rather than just learning to learn. So that's all I had. So thank you.
Okay, so good morning, everybody. Good afternoon, everybody. I just realized that it was the worst idea I could have ever get to talk after Derek, but we will try to figure it out. So I'm Veronica Pederiva. I am Italian, so I will not talk as good as Derek. So I graduated here in Padua in computer science in my bachelor. This one is better? Okay, sorry. And now I am again a second-year student, and I'm doing my internship in a company here in Padua. It is BMR Genomics, and as the name said, they work with genomic data, and in particular, I'm working on data from a disease which is ulcerative colitis. And why I'm here? Because I want to talk to you about my choice in this degree, because I choose the biological curriculum, of course, because this is also the argument of my thesis. And it is because in my bachelor, I already explored the computer science. I studied computer science also in high school. And what I wanted to do with my master degree was to explore new fields of application of computer science, because it is nothing new that I say to you that information technology is everywhere. But what we can do with data science master degree is to see its application in very different things, as you see in the curricula, in the presentation that you saw this morning. So why I choose the biological curriculum is then because I think that information technology could really be used in things that can help people. And I think that this is the goal of medicine, and especially today with the help of artificial intelligence. And not to say that the other fields are not important, but that was my choice. So this presentation is just about the results that I have got in my first month of internship. So it's just to have to give you an idea of what I'm doing. I hope that some of you have chosen the biological curriculum. Is there anyone? Yeah, okay, great. So the data we are working on are from patients with this disease, which falls under the disease of IBD. And we are comparing them to a control group, which is something that is basically the norm in medical field. What is special about this data is that they are high-dimensional data. From here, you wouldn't say that, because these are the data about the patient. But what we are working on, this is just the EDA. What we are working on is actually the composition of the gut microbiome. So it's like the microbe that lives in your gut. And what you are working on are those huge tables where you have thousands of lines that you need to process. And this is the pipeline that you work on to process the data. And not to joke, it took like 1 week and a half to process all the data. And it was only 20 patients. So that also goes again to what you heard this morning, that computational efficiency is what you need when you work with big data. And I say to you also, another thing later. So what you can do in the biological field is to explore the biological composition, to do all these analyses that are not very interesting. But these start to become more interesting because what I noticed and what I was afraid of before starting the internship was that the gap that might exist between the academic life and the real life. So I was afraid not to be prepared to go to the real world. And actually, that was not the case. Because, of course, when you are during the course in the university, you think that you are working on game datasets, per se. But then you understand that all the theory that you have studied actually help you to understand the data you are working on in real life. So like the box plot that you see on the right, that is the p-value, so you know what is significativity. So once you know that concept, you can apply it everywhere so you can understand the results that you get. And that is the most important thing because the tools that you are going to use are not important. You are going to learn the tools that you need to use, and what you need to understand are the theory concepts that are behind that, and also to understand the results. Because another thing that we explore was PCOA, that maybe you know that, because maybe machine learning, deep learning, you saw that concept, and that was used to explore the difference between communities, and here is another thing. Here is an important concept because differential abundance analysis, at the beginning, I was afraid because I told them, I don't know what this is. But then I look at the tool and I understood that what we were doing were just basically t-tests between the different communities. So I know that all of you know what are t-tests, and because you saw that in statistical learning. And so again, this is to tell you that once you know the theoretical concept, then doing all these analyses and exploring them, this is a correlation matrix, so you know what is correlation, how to study them, and the thing that is important that you understand is how to look also for solutions, is basically how to Google things. My advice is learn how to Google things and how to look for papers. And I know that this is something that, fortunately, in our degree, we do a lot. Because, for example, the course that also Derek was talking before, Human Data Analytics, I know that some of you already take that, learns to teach to you how to look for literature and previous work. So from this year, I know that what I enjoy a lot about this degree, but also I find difficult to do, was all the projects that we have to do. But they helped a lot, because the next step in my internship was to define a random forest classifier. So it was basically Python, and it was basically a machine learning model, and I knew how to model that and how to use that, and then how to look at the results and feature importance and how to perform cross-validation and grid search and all this kind of stuff. So I don't know if you have my fear also to have this huge gap between academic and the real world, but I can tell you that it doesn't exist for me, because really I learned how to be also independent on how to look for things and how to use what I learned in my internship. So these are the results, and then the next thing that we did was to look for data on the internet that were from other studies and validate our models, and the results were not pretty good, so I will skip that. But so this was very fast because I just wanted to show you everything that I were going through. But please, if you have questions, I will be much more happy to answer all your questions than to present myself, because I don't like that. I'm not Derek.
Okay, hi everyone. My name is Alberto Bernardi, and okay, today I will quickly talk to you about my experience with the data science master degree so far, because I've been a master student of data science since October 2019. And before of that, I got my bachelor's degree in mathematics here at the University of Padova. The bachelor's degree in mathematics kind of provided me a good background, a solid background by the point of view of math skills and tools, of course. And all these tools kind of allowed me to look at the problems and all the theories a bit more in depth, and made me want to try to take a step further in understanding all the topics that were presented during the various courses. And that's why then I continued doing some internships, a couple of internships in which I worked on some research problems. So we'll talk about this later. But first, what you might not know, I don't know whether this is the case or not, but I studied this bachelor's degree in 2019, and it was the last year in which you didn't have the 4 curricula. You had to just one curriculum, and you had some mandatory courses. And in particular, well, you had 3 mandatory courses, which were cognitive, behavioral, and social data, business, economic, and financial data, and biological data, which were from, as you probably know, psychology, biology, and economics. And even though at the time I was not really very happy of taking these courses, because I didn't really have a strong interest in any of these fields, what I realized later was that even if the field might be very different from the one you are currently working on, you can still get some insights or can take advantage of the point of view presented by different fields in order to go deeper into your problem and kind of find a new solution to the problem you're working on. So, so really, as Derek was saying before, do what you like, do what you're passionate of, because even if you don't have the constraint of having to follow this, this course, you don't have these mandatory courses, if you like them, you really have to do them, because even if you don't think they will be useful later, they might be, because they really can give you a different point of view on things. Other than that, what I've been studying during my master's were mainly courses related to machine learning, deep learning, probability. And one of the main interests that I matured during my studies was the one for unsupervised learning. And since there are no, well, at the time at least, I don't know now, but there were no courses that were really going in depth into unsupervised learning. Human data analytics did something about that, also some other courses, but just tiny bits. I kind of wanted to go deeper into the field. And that's why when it came the time for deciding what kind of internship doing, I decided to do a research internship, trying to look for something that was related to unsupervised learning. So mainly because of COVID, I chose as my first internship the internship at GSSI, so the Gran Sasso Science Institute. During my time, not there because it was done remotely, but during my time in which I've been working under the supervision of Francesco Tudisco, I've been working on a problem which was related to unsupervised learning. It was more precisely semi-supervised learning. But it also combines some notions of deep learning, and well, the idea of the problem is that you have a network, you have a few labels available, and you want to spread the information of this few label to the remaining part of the network. And so we tried doing this with a deep architecture, and yeah, it was very interesting. I'm not going into details. I hope you don't mind. If you want some more details, well, we can connect offline, and basically I can give you this further details. But what I wanted to tell you more importantly is that the GSSI is one of the institutions that is affiliated with the University of Padua. And so this affiliation, there are many other companies and also institutions that are affiliated with the University of Padua. You can for sure find a list online somewhere. And this is very helpful in the sense that when an institution is already affiliated with the University of Padua, you have a direct contact with that institution through the university. So it's easier if you want to do an internship at these institutions or companies. You can go through this person at the University of Padua and immediately get in contact with the other institution. And so it's easier to start everything. Instead, if you want to do an internship or with a different company which is not affiliated with the University of Padua, you have to try to contact people, get an interview. So it might be a bit more difficult. It's definitely doable, but for sure, I really recommend you to check out the affiliated institution and companies, because there is plenty of option, and that can really help you if you have no idea what you want to do, or just have some tips on what could be your path. So after this internship, actually, I did another internship, not because it was necessary, but because back in 2020, I won a scholarship for going to study at the University of British Columbia in Vancouver, Canada. And then because of COVID, I had to delay this possibility, of which I was not sure until the very end, when I went there last September. And I studied there for 6 months. I came back 3 weeks ago. And there I've been working on a problem which is related to combating fake news under the supervision of Lux Lakshman. And this has become my thesis that hopefully will become the thesis with which I will graduate in 10 days. So yeah, and well, the problem is about combating fake news. We didn't focus on the detection side of the fake news, so in developing a tool for detecting the fake news on the social network, but rather we studied a more mathematical problem on how to alternate different counteractions for combating the diffusion of fake news. An interesting thing here that I think might be of interest for you is how I got there, in the sense that there is this Ulisse program, which is basically I don't know if you're aware of it. How many of you have ever heard about the Ulisse program? Okay, well, a few of them, and this is most of the times the case, because it is basically the equivalent of the Erasmus, but most of the destinations are outside of Europe. So the thing is that if Erasmus is very popular, Ulisse is way less popular, and most of the times people don't know about it. So this is bad on one side because it's a great opportunity. I can tell it's been an amazing experience. But at the same time, when people don't know about it, you have less competition. So when you apply for it, it's easier to be selected. And then you get a scholarship, which is kind of consistent, so it's really helpful. And so it's definitely a great possibility. And just one more pointer about this is that you have two types of destinations in the Ulisse program. One is the Ateneo destinations that, as the word itself says, is open to all the students inside of the University of Padua. And this, of course, kind of increases the competition for those destinations. But then you also have some department destinations, which are just targeted to the people inside of a specific department. So, for example, the Department of Mathematics, just the people inside of the Department of Mathematics can apply for those destinations, and so the possibilities of being selected increases even more. So you should definitely check out that. And yeah, I went then to UBC. I worked on that problem. If you really have the chance and you want to travel abroad and make a research experience in a different environment from here, that can be extremely beneficial. You see a different way of approaching to research. And so if you are into research, I definitely recommend you to do this kind of experience that you could really benefit from. And I hope I did. We will see. But yeah, it was definitely great. And that's pretty much it, I think. That's summarized. Oh, okay, here is not as it was supposed to. But there should have been my email address there. So if you had any further question, inquiries, or whatever, you could have just contacted me. I don't know if we managed to recover it, but yeah, otherwise I will give it offline, or if you want to just ask any questions right now, you are free to do it. And so thank you for your attention.
Okay, so time for questions, if any. I'll just stay here to, I'll be the moderator. Anyone? No questions? Oh, okay, great. Wait a minute.
You guys stayed offline, like you used to work in person, yes?
The first year I worked in person, because I started in 2000. You mean during the internship?
Yes, just.
Okay.
Yeah, sure.
Okay, at the Gran Sasso Institute.
Okay. Closer to the microphone, please.
So at the Gran Sasso Institute, so the first internship, I did it remotely. Instead, the one at the University of British Columbia, I was there in person.
I remember that we studied at the same course, so I'm interested. While you still continue your degree, you stay connected with the company online? Like, how do you contribute to the company's business? Yes, yes.
Yeah. So right now they're allowing me to just work part-time, and ever since, like, I started last summer as an intern. I did my 3 months, I finished. They hired me full-time immediately after, but it was full-time with quotes, because they essentially said, you can work whatever hours you want until your thesis is completed. And that's how, and so I just work, right now I pick my own hours, and whenever I want to work, as long as I just tell them what I'm doing and meet with them, that's just kind of the arrangement I had, which is very nice, actually. But it has been kind of interesting coordinating both work and school all at the same time. So does that answer your question? Is that what you're curious about? Yeah, okay.
Would you recommend to do something in summer? Like during the summer break, was there something that you did maybe that helped you maybe with the degree, or you basically chilled and did nothing? You know?
Okay, if I can go first. I would definitely, I did something with the GSSI. Part of the internship was done over the summer. That might be done if you want to chill, if you have the time to chill also. It depends also on how much you want to strive, how quickly you want to graduate, what kind of work you want to do. Because if you want to do an internship just for doing an internship, then it makes sense to chill during the summer. If you instead want to really put a lot of effort into it, then it can also make sense to work over the summer.
Thank you. Thank you.
Anyone else?
I have a question.
Oh, go ahead.
Sorry.
Just on the same question, I would say just if there's an opportunity, don't turn it down. You know, look, but for me, it just presented itself. Otherwise, I would have taken the summer off and just relaxed. Very much needed relaxation that I don't think I got. So.
I think that, of course, as he said, if you have the opportunity, just take it. But what I've learned in my bachelor especially is that is something that maybe many people do not talk about this, but also take the time for yourself. So what I did last summer was to prepare an exam that was extra because it was the elective, because I did both the elective at the first year last year, but it was only one exam over the whole summer period. So I also took the time for relaxing for myself and enjoy all the other things of my life that was apart from studying. And really, I know that I'm not 50, so I didn't so all my life. But really, do not focus only on study and follow your passion, not only on study and not only on work, but also take care of yourself. So if you have the opportunity to work in summer, do it. If you want to study, do it. But also take time to relax.
I have a question for you, Alberto, right?
Right.
Okay. How did you find your supervisor in British Columbia? Like after applying for the Ulisse program or before?
Okay, right. So first, I applied for the Ulisse program. Once I was selected, I started looking for a supervisor there. It took me a lot of time in the sense that when I was saying that the affiliated universities, you have a direct contact there that kind of put you in contact with the right person is very helpful, is because finding the supervisor was something that I had to do by myself. Basically, Professor Ferrante had some contacts there, but of course I was studying something unrelated to that topic, so I had to find a supervisor by myself. You send a lot of emails, you wait for the answers. Most of the time the answers don't come, so you really have to send a lot of emails, be patient, it takes a lot of time. But in the end, you will figure out, in a way or the other, you can find someone. That's something that I've learned.
So you first find this person, and then you propose the thesis, like the topic that you wanted to...
No, actually, I found a person, and then he proposed me some topics. I had a general idea of what I wanted to work on, something related to graph learning or unsupervised learning. And so I looked for a professor that satisfied these requirements, and then once I identified a few professors, I tried to contact them. But I tried to contact multiple professors, and just 2, 3 of them answered me back, and just once in the end proposed me something that was really interesting, and so that's the one that I accepted.
Maybe if I can add a few words on that from on the other side,
okay.
Because I think that's an important question, and actually UBC is a good example, at least in my experience, because I have several students that have been there, but I think also in almost everywhere is the same. So what I definitely agree with what he said, but one suggestion on my side is that it's very likely that you not have, like probably is your case, you don't have a clear idea about what you want to do, but for sure you have an idea about what are your general interests, the area, and so then you try, maybe by yourself, to match that area with the people, for example, at UBC that are working on that. But usually you have to do also the same, that is probably what's happened also in your case, with the internal supervisor that might help in that. So for example, UBC, I had 3, 4 students at this point that went there, and for example, he actually is one that is not as close to my interest, is in general on the machine learning, deep learning area, but it's the case. I mean, it's close to what I'm doing. I'm mostly working on computer vision. I have 2 persons that went there, and there are 2 or 3 people that are very good in computer vision. Actually, I know them, but they never reply to, to your email. So it's never happened that the students that try to contact one of them got any reply. And so usually, obviously, if you have someone, like in this case me, that that maybe in the loop is going to help, or I can provide, in that case, info about maybe this is not an option because it is not going to take students, but maybe there are these other options. So usually I think you have to take into account, or to consider both. So the area, what eventually could be the internal advisor, that is very likely that in a case such as this one, in which we are going to work for 6 months with an external advisor,
I mean, 99% of the job is going to be done by the UBC advisor in this case, but having someone that can help you in the process is definitely an option. And also, Ulysses, I think, is a good example because it's true what he said, that I think there are a lot of good, huge opportunities there. Another one is Boston University, for example, which there are very great opportunities. You have the chance to go there basically with a fellowship that cover your period over there. So there are several options that not all the students are aware of, and so I think that trying to understand what could be or what are the options for you early on is a good thing to do. Then maybe you understand that, maybe you can decide to do something else, but there are plenty of options. So, anyone else?
Do you consider studying PhD after master's? Not really.
I'm sorry?
A PhD degree, does anybody consider?
Well,
I would.
Or go into industry.
Don't be scared.
It's been offered to me. I think I need some time before I have to take another exam or read more research papers. I would consider it, but at a much later date, for sure.
I'm not, so.
Okay. I'm considering it, but I think it takes some time you really have to be sure of whether doing it or not, so I'm thinking about it. We will see whether I will do it or not.
Okay. So, thank you. No one else?
Welcome.
Okay, super efficient, actually. Thanks. I think Francesco, so I think we can move on with the schedule. And so I think Francesco is going to introduce our next and last speaker.
Okay. So let's welcome our last speaker of the day, Francesca Giancola from Ahead Research. She kindly accepted our invitation. So Francesca, thanks for being here. I'm very excited about your talk.
Hi, everybody. Thank you, Francesco. I'm sorry for my voice, but I have a bit of a sore throat, and I'm also really nervous, so I took with me some water. So if I feel like I'm dying, maybe it can help. I don't know. I introduce myself. I'm Francesca. I'm 25. And I've been working for 1 year and a half in Ahead Research. And I am a modeling and simulation engineer. And I graduated both a bachelor and master degree in management engineering at Sapienza University of Rome. And I decided during my master degree to focus on topics of optimization and simulation. But I choose for my master thesis a machine learning topic with the team of Ahead Research in a comparison study of regression models for the prediction of number of clicks in a digital advertising campaign. I fell in love with the reality I met in the company, and I decided to stay. But I changed a bit the topic of my research, and so now I work on simulation models. I will present a little bit my company, who we are, what we do. Then we will do a brief theoretical framework on operations research methods like optimization, simulation, and simulation-based optimization. And then we will see some applications that we face in our company. Ahead Research was founded from the meeting of two Italian companies that are Spindox and Actor. Actor provided for 20 years solutions based on artificial intelligence algorithms, while Spindox is a company in the ICT sector, but really believes in the power of technology, skills, and experience to make the business of its customers to grow. So as research was founded as the research center of Spindox. We provide artificial intelligence consultancies to our clients and try to support them in the whole process of analyze the problem, what they need, develop the algorithm, and provide them, present them the solution to make them understand the power that there is under an artificial intelligence algorithm. Another focus of our company is on research, as our name could suggest. And we have strong relationships with the university in all over Italy and also with international universities. And we collaborate in terms of internships, PhD programs. We work together on grounded, funded projects. And we try to follow the innovation and do always better. Also with the University of Padova, we had the pleasure of work with many students and internships and theses. And we are divided into 3 teams, a mathematical optimization team, simulation team, and machine learning team. Here we have some of our industrial projects that we face to support our clients. For example, we work on inventory optimization and replenishment, and we support clients in the fields of energy, like Enel and Iren, or in the field of large distribution, like COP or CONAD. We work also on supply chain and warehouse optimization, transport optimization, forecasting and machine learning, and production workforce planning. In this last case, we have a really interesting solution for Moncler, where we built a simulator, a real-time simulator that suggests to the operators what to do, which task to execute in real time, considering the state of the process, the products that are flowing into the warehouse. Now we go through the operations research teams. Operations research is the branch of applied mathematics in which complex decision-making problems are analyzed and solved by means of mathematical models and advanced quantitative methods as support for the decisions. If we talk about mathematical optimization, we have to consider the formulation of a problem with objective function that we want to minimize or maximize, a set of constraints that define our domain, and the decision variables. And to optimize this problem means to search the optimal solution that respects the constraints and satisfies our needed. Sometimes optimization problems can be very complicated because of the dimension of the problem. We can have millions of variables, or also the definition of the objective function can be so complicated that you cannot express it with the analytic form, and you need to compute the value of the objective function in each single point. And this can be really heavy from a computational point of view. So we ask the support of other techniques like simulation or machine learning. Simulation gives the opportunity to replicate a system in its whole and to create a virtual digital twin. In this way, you can understand all the single components of the system and evaluate it in what-if analysis. You can see what happens if you change some variables without spending all the cost you should spend doing it in the real world. To build simulation models requires deep analysis of the system to understand all the variables, all the resources, buffers, the dynamics that are inside the system, and to find also some stochastic definitions of the parameters, because we have some stochasticity that is natural in these systems, like for example, the failure rate of a machine. You cannot know it's not regular. So we try to estimate some probability distributions, and thanks to the simulation, we can take into account this important aspect of the real system. Then we have to validate our model to be sure that it really represents the real system. And finally, we run the simulation considering different replications to assess the robustness of the KPIs that it gives you in output. So we have statistic KPIs, and we consider mean values and try to take all the information we can from these tools. Here are two pictures of 3D simulation models. The first one on the right is the warehouse simulation that follows the product from their arrivals in the warehouse until the storage, picking, shipping, all its flow. While the second picture is an automated system simulation that is focused on the slotting, the positioning of the product on the shelves. Simulation-based optimization is the integration, the combination of these two techniques, and is considered when the problem is too complicated to be formulated in a mathematical optimization problem, and it's not enough to use one of the two tools. So we combine them in an iterative procedure. That is, we have the optimization program. It gives selects some input variables for the simulation. Then in the simulation, we estimate the performance KPIs, values of variables, and giving output these values to the optimization program that evaluates if you are in a good point and if a stopping criteria is satisfied. A stopping criteria can be, for example, a number of iterations or a value, indicative value of the objective function. If we met the stopping criteria, then we can say we are in an optimal or suboptimal point. Else, otherwise, we have to evaluate another input variable to give to the simulation. Now we see some applications of this approach to real industry cases. I selected three classes of problems that are the most typical in this case of interest, and are the capacity workforce planning. There is a process that balances the available resources to meet customer demand on the project capacity requirements. And capacity is the must work that can be done over certain time frames. So we have to find the capacity needed to satisfy the demand or necessity. In inventory optimization, we have to determine inventory levels to meet customer demands, but to keep the cost low. So this is one of the most popular trade-off of industrial problems. So we want to satisfy the demand, we want to feel safe with uncertainty, but we have low budget, so we want to be efficient. And optimal design and layout of industrial facilities is one example of one-shot decision. You want to design your production plant, and you do this once. And you want to do it in the optimal way, so you evaluate some scenarios, you see how many resources you should consider, in what is the position you should collocate the resources to make the process most efficient. Workforce capacity planning. We see an example for car rental, where the leading European car rental company has the mission to be an attractive alternative to vehicle by providing a wide range of mobility solutions. The car rental environment is very competitive, You have millions of websites that compare to you all the companies, the prices, the service levels. So to grow with a business in this field, you have to be efficient, maintain low cost, and have an optimal process at the base of your business. So we provided to this company an optimization of the fleet capacity. The main criticality of this process is that you are dealing with some factors that doesn't depend on you. Like, for example, the customer behavior. You don't know when a customer will give you back the vehicle they rent. You don't know where they will, in which station they will leave the car. So you have to understand what is the best fleet configuration, where your vehicles should be to be ready to face the demand. But this is not trivial. You have costs of transferring vehicles between the stations. You have costs in buying new vehicles, and so on. We developed integrated solution in 3 main steps to face this problem. We have the first step, that is the forecast engine that provides the expected daily checkouts, where checkouts are the daily new rents, considering the historical data and some calendar events or weather conditions. So we forecast the daily new rent. But this is not enough to understand how the system will react to this demand. So we have to consider a discrete event simulation that gives the possibility to see the current status of the system, so the current fleet, the fleet and transfer plans, so where are our vehicles, where will be, where we plan to move them, and then the rental agreements and reservations. Given this input, the simulation gives in output the expected revenue that we want to maximize and the expected rental agreements and vehicle utilization. Here, the optimizer takes in input this information and tries to understand if this is a good solution. If yes, okay, we solved our problem. If not, it tries to provide another in fleet of the vehicles, and we try again with the simulation to see what happens if we consider this configuration. So when we meet the stopping criteria again, we have found our optimal solution. Now we see the inventory optimization case applied to a large distribution company, where we have to find what is the optimal quantity of safety stock for each product. The safety stock is the minimum level of stock you have to maintain to be sure you will absorb possible unforeseen events and you will face the demand. To do so, you have to face problems with demand fluctuation, the error you commit in forecasting the demand, all the stochastic times of unleading, refilling time, lead time, that is the time the supplier needs to send you the order you do, and also the possibility that when you receive your products, there is some rejects. There are some rejects. So also we are dealing with a huge dimensional problem, because we can have millions of products if you think about a supermarket, and you have to optimize the safety stock for each single product. Oh no? Or you did? Okay. Here we have again our simulation-based optimization. We receive input data for each product. We try to optimize and simulate, and receive in output the safety stock for each product. In this case, our optimal functions want to consider the average stock you have for each product, the exhibition stock out, and the stock out. And we cannot calculate these informations if not with the simulation. the simulations reproduce the two main processes that characterize this problem, that are the order process and the sales process. While you have the order process that goes to increase your stock level, and you have the full control of order process, because you decide when, how much product you want to order, you cannot control the sales process. You can just do some predictions, but you cannot have the security that it will be the actual values of the sales. So with the simulations allows to reproduce these two processes in parallel and gives you the final level of the stock for each product. And given these values, you can optimize the stock level. Another similar problem was about the energy and utilities environment. These companies asked to us some support to optimize the stock level, and we obtained optimal results. We managed to reduce the working capital cost associated to the warehouse by around 47%, and the stock out reduced by 28%. And even if the safety stock level was reduced, we were in a more safety situation. Last application is the optimal design and layout of industrial facilities. And here we had to support the designing of layout and sizing of a new precast concrete production plant. And here the main process criticality were the fact that we had several automated systems that interact with each other, and many shared resources in different production processes that had to work in parallel, and several pauses in the production given to some activities that required waits or just time to get wet the painting and so on. Here again, we used the simulation to create the digital twin of the production plant, and we tried to see what happens when we change a number of resources or resource allocation. And we used the black box optimization to select the best performing scenario. And so we arrived to the conclusion that the starting hypothesis of layout and design of the production plant was wrong, and suggested, for example, 3 cranes instead of 2, because with 2 it would have been impossible to meet the demand, 2 backends instead of 1, and we identified a min-max range of operators needed to carry out the activities. So what this approach allows you to do is to see that sometimes when we do hypotheses and try to understand how to manage things, we cannot do it alone. We need the support of an algorithm that tells you the real configuration based on mathematical data. Okay, so this is our concept.
So, is there any question or comment related to the, okay? Is the microphone?
Thank you for the, thank you for the presentation. You show in the middle 2 pictures from simulation.
Yes.
And I was wondering, I mean, were like real 3D animated stuff. I was wondering, is that really the animations you use, or do you use?
Yes, it's, so we use the simulation software to reproduce the system, and the simulation software allows you to do this 3D representation of the whole system. So you can see the simulation with the product that moves in the system.
Because I was wondering, for the optimization, you do not need to see it probably, right? You just need to like have the variables and they go through it. Like, is that to produce, like, to show something to the customer to make it more understandable, or is that does
yes,
it have
yes.
a,
It's
okay.
when you show to the client what you can do with the simulation. It's easier to show the video of the simulator than to say, okay, I can give you these KPIs, resource utilization, and so on. If you show them the video, they really understand the power that there is behind the simulation.
Okay, thank you.
Thank you.
Any other question or remark, comment? Okay. If not, let us thank again the speaker. So we actually have plenty of time for the closing session, but I guess, I don't know if somebody wants to add some more words. Marco, Umberto, okay? We are all tired, I guess. And so we still have some Saturday afternoon to enjoy, hopefully not rainy afternoon. So guys, it was really amazing having all of you here today. I mean, it was a big effort for us, but I mean, seeing you here, interacting and enjoying this time, asking questions, and seeing all the other students talking with you guys, I mean, was amazing, really. I hope this is not the last time we do this. I hope next year we will be able to organize again. I mean, we'll have the strength to organize again this event because it was really demanding, but I mean, it paid off, I guess. And I hope you enjoyed this nice place, and you enjoyed the event, and you now know something more than before. And that was the point, the main point. And you also had the T-shirt that is very important, right? So, Marco, if you want to add something?
Yes, just one thing, and to be prepared, 2 or 3 of you, to be here next year to present your experience in data science and to give this, okay, pass of information to the next generation. And maybe we will try to organize more interactive situation for you yes, it's not so easy to make question to people here, and so we'll try to have a more interactive part. But I think that it was a very, very good occasion to stay together and to have, well, the description of the second semester of this year and what may happen the next year. And as your class, yes, older friends said, enjoy your summers and relax. As you know, people say that the life is short, but it's completely false. Life is very long, usually, and so you have to fill your life with many things to do. And so if you spend a couple of months more, do it without any problem. But continue working, and you know that if you push when you have this age is the best moment to do this, but you have not to forget to go outside on Wednesday evening in Portello and do things that you don't want your parents know or even your friends. But so for a small while of your life, you can enjoy this, and then you became again human beings and continue your life. Okay, I always teach on Thursday morning, 8:30, and so it's terrible to see your faces when you are in class after a Wednesday evening, but it's something, night, sorry, not evening, morning, I don't know. Okay, but I hope that you enjoy this. Welcome to data science. After 2 years, we were able to do this, and for sure we will, since I'm not organizing, I can say that for sure we will do every year in the next years. And we will ask help to you to organize this, and so to make it more collaborative. Lamberto, you want? Yes, I am sure that you want to add something. Come here, don't be shy.
Okay, no, actually, I don't have much to add. Only that, as was said, we tried to do this event multiple times. So the first time was immediately, as already been told, has been before the COVID pandemic. This year, it was before the war started, so now only, I mean, I don't know what's going to happen, but we will try again. So I don't know if this is something that everyone is expecting, but we are doing this again, or we'll try to do it. But anyway, I think that this is this is not only related to today, but I think this semester, at least to me as a lecturer, as a teacher, it is nice to see again people around and to have the opportunity to interact. And so let's try to do this more, even more than today. I think this is at the end the experience that everyone is really enjoying, and so yeah, I'm happy for that, and thanks for being here, everyone. So now it's spritz time. Okay.
Any other question?
Yeah, if you now we have time offline. So if you want to have, if you have questions that are more related to, let's say specific individual issues, we are here for, I think, for an hour or half an hour maybe. So enjoy the weekend.